Hello, I am back, and welcome Bob Marley, Doffy, and Tetsu Paul. Thank you so much for passing by. Always great to see you. And yeah, Doffy, you know, you were definitely first yesterday, but as I mentioned, sometimes Bob Marley is first, and I think today he beat you to the punch. But regardless, super grateful, have you both of you or anybody stop by, and also shout out to Tetsu Paul, fellow streamer, but workout and fitness and IRL hiking, kayaking streamer. One moment. Where if you're not following them, could be, because yeah, they make great content, and also they're Canadian, so all the more reason to follow. And yeah, I'm trying to stick to my schedule that I posted in the Discord. Although not off to the greatest start, because I was supposed to stream on Sunday and that didn't end up happening. But like, yeah, I'm streaming now. I plan to stream tomorrow, and I'm probably gonna make up for the missed stream on Friday or Saturday, probably Friday. But trying to bring the content regularly, but no guarantees. And also, again, still trying to resurrect the workout and fitness streams. And hopefully, the increased content is a good thing. And hopefully, yeah, I can maintain a certain level of quality. I'm not gonna lie. Like, I have a lot of content like prepared, but also at the same time, I want to make sure that when I cover research, I'm trying to at least, do my due diligence beforehand and make sure that I, at least having some understanding of the research that I'm covering. I'm hoping that basically, with the increased quantity of content, that quality is not sacrificed. Not that I ever had super high quality, but at least I'm trying to maintain some semblance of quality. And I'm super glad to hear that and grateful to hear that, Bummer, that you got great advice on that work. And yeah, like, I had fun as well. I'm also glad to hear that you're working out. Are you doing? Are you using your home squat rack? And have you started your adventure with squatting? But like, yeah, I'm still on a mission to bring back the workout streams as best as I can. No promises, but I really am trying, because yeah, they were fun for me. I think they were fun for at least the people that were interested in them. So yeah, gonna do my best. And yeah, yesterday I was streaming, and I covered what I think was a really great paper on engineered bacteria, synthetic biology, that I thought was super interesting. And it took more time to cover than I anticipated, but that's not a problem at all. I had my original stream plan of covering, 2 papers. I ended up covering only 1, but now I just get to cover now what I didn't get to cover yesterday, and that's why, part of my stream title from yesterday is still the same today: the exercise and rejuvenation of skin. And then there's another paper that I sort of wasn't originally planning to cover, but I'm covering it because it actually overlaps nicely with some things that were brought up yesterday. With touched upon the microbiome a little bit, like, just, a very surface level covering of the microbiome. But I brought up that sampling and characterizing the human microbiome is difficult, and very often we're relying on output waste of humans, or essentially stool samples, and that what's found in stool is not necessarily reflective of the microbiome. But we do that because it's convenient, and that it's very difficult to there's bacteria throughout the entirety of our GI tract, but a large portion of it is like inaccessible, or like it's only accessible through very invasive measures. And so it's like, well, we don't really want to subject people to these invasive sampling methods. And so we either, like, maybe go a stool sample or like colonoscopy or whatever is accessible with an endoscope. But even then, there are challenges there. Um, and I brought up the fact that I'm sure there's probably in development of like as of now, today, or like the past few years or like decade, we have had capsule endoscopy. It's just pretty much a visual colonoscopy in pill form. Although it's pretty much the entirety of your GI tract. You're swallowing a pill camera. And I brought up the fact that probably at some point there's going to be like, a capsule endoscopy, but it has the ability to actually, take samples of your GI tract. And I started after that, or earlier today, I started like doing a little bit of digging, the research, and lo and behold, this technology, no surprise, I guess, is in development. And it's like very recent, as in the paper that I'm going to cover, was published just a few months ago. And it's pretty much like literally, hey, this is a new pill camera technology that has the ability to take samples as you swallow it and it passes through your GI tract. So I'm happy that my prediction came true, or like yeah, pretty much in retrospect, what I said was true. But diving right into it. The best part is the 3 a.m. workouts. I've just started squatting now, but I'm weak with them, I think. So yeah, Bob Marley, be careful with the depth. So even though I emphasize squat depth and I emphasize mobility and flexibility, but do not, especially when you're starting off squatting and you're new to it, it's better to develop, good and healthy habits when you start something, as opposed to like, trying to correct something after, you've habitually done something. What I would say, and my recommendation would be, and take it for what it's worth, if anything at all, is like, go down to, the depth that you are comfortable. Okay. Pretty much do not sacrifice form or technique for increased depth. Work on depth of squatting, sort of outside the squat in terms of mobility and flexibility exercises. Or like, maybe pushing it a little bit, but you only like emphasize depth in your squat with pretty much much lower weight, and weight that you can fully control. Or things like, elevating your heels, or like getting like weightlifting shoes. But yeah, pretty much, generally speaking, I would say only squat to the depth that you feel comfortable with, and that your current mobility and flexibility allows, and that allows you to keep your feet fully planted on the floor throughout the entire duration of the movement. If whenever you're squatting, and you start descending, and either your heels you pretty much like your feet go off balance, either you'll hear your heels start elevating, or like it'd be a little bit bizarre, but like, oh, you're leaning too far back, and there's like more pressure on your heels, then like, yeah, that's an indication that you are likely going too far down. The depth I'm comfortable with is pretty much as low as it goes. Everything else to do is like a half rep. Even if it's a parallel, but I do use plates for my heels already. Okay, yeah. So if you're already using plates, yeah. But even then, if it's a half rep, that's totally fine. At least for now. Like I said, I personally, okay, I would encourage like developing good and healthy habits from the get-go, as opposed to trying to correct something way down the line, or like you have to learn a brand new movement pattern when you've been practicing a specific movement pattern for a long time, or months or years. Yeah, I would say generally, obviously you can never be perfect, but still, I think you should err on the side of caution. So it's not a matter of like, whatever, how many feet or inches off the ground. It's like whenever you're descending, like, so what I would encourage I recommend is pay attention to your feet. Pay attention to the distribution of your body weight on your feet. Okay, and that when you're standing up and you have the barbell on your back. Okay, and obviously a little bit challenging, coaching through just like whatever virtual means. But like I'll do the best I can in terms of like just some fundamentals of like when you have the barbell on your back and you're standing up straight, you're pretty much at the beginning of the movement. And then when you start the descent, go down, like pay attention to the distribution of your body weight on your feet. It should pretty much your body weight distribution on your feet should be evenly distributed on your feet ideally throughout the entire duration of the movement. If pretty much whenever you're off balance on your feet, either you're too far back or too far forward, that is likely, especially as you descend, okay? As in, like, if you ever get to the point, okay, in the descent, that you absolutely have to, as in you can't get any lower without shifting your weight, as in you have to either lean forward or lean back on your feet, and that is pretty much like the limits, as in only go as low such that you can maintain the even distribution of your body weight on your feet. That is, I think, a good cue to pay attention to. Like your feet firmly planted on the floor. And that, yeah, once you start the descent, and like you feel like you can only go lower if you start shifting your weight, either forward or backwards. That is the sign that is your limit. Yeah, I think that's a pretty good sort of thing to keep, at least to get you started, and at least to keep you in sort of in the ballpark of overall safe, and hopefully developing good movement patterns from the get-go. And yeah, the more that you, I would say, get in tune with your feet, the better. I know, it's not natural, but it will also help you for like pretty much just about every exercise, not every, but like a lot of exercises, such as the deadlift, if ever you want to start deadlifting. The same principle holds true, as in like your feet should be firmly planted on the floor, and your weight should be evenly distributed on your feet. And speaking of strength training or resistance training, pretty much that's what we're going to start off with, some research on resistance training. But it's not in the realm of building muscle, or rather it's not in the realm of like whatever specifically building muscle, but it's in the category of anti-aging, or like most people now are aware of the benefits of exercise when it comes to your health, both your physical health, maybe your mental health, and your psychological health, and your cognitive health, brain health overall. But then there might be some other aspects of resistance training or just physical activity overall when it comes to this might just fall in the realm of like aesthetics, or yeah, just how your skin looks and feels. And you have started deadlifting now. That's fantastic. Well, are you like teaching yourself, or you have someone like teaching you, or are you going by like YouTube videos, or just experimenting? But yeah, same principle holds there, of like the more that you start paying attention to your feet, I would say the better. And then the more that you can actually start feeling the weight in your feet, start a movement. That's I think that's off to a good start. I think it will pay dividends over the long term. Same thing with easier said than done for many people. But the earlier that you focus on mobility and flexibility, the better. Just weak with it, I bench. Well, that's totally normal. Or rather, it's not like abnormal. We all have, well, you've invested way more time in benching, so like it only makes sense. And like for deadlift, you know, I have no doubt that the strength is there, and it's largely like a technique issue. And that, you know, once you get sort of the technique down, and the appropriate cues and form, like I have very little doubt that your deadlift will adjust, exponentially take off in the beginning, and that you'll like pretty much you'll make quite a bit of progress first few years. Although you'll consistently make progress if you practice it, the right diet. But yeah, it's largely a matter like it is largely a matter at this point when you're learning a movement. It's not like the perceived lack of strength is almost certainly not coming from, you know, a lack of muscle development. It is likely the neurological changes required to like learn the movement pattern. And pretty much, I mean, that is actually pretty much the whole concept of, you know, what they call newbie gains. So like, why do people, when they start resistance or strength training, that, you know, in the beginning, they see a lot of progress? Well, that progress isn't actually coming from actual, you know, increases in, you know, muscle protein synthesis. It's not like you have some advantage or like your muscle protein synthesis like tapers off after a year or two, taking, let's say, aging aside. But it is largely driven by neurological changes, as in your brain adapting to, you know, pretty much incorporating your muscles, or rather recruiting the motor units of your muscles. Like, hey, your brain now is like trying to wire itself to like, oh, okay, I can actually now, you know, start generating force, or like, you know, I'm starting to learn how to recruit most, or, you know, a majority or all of my motor units in my muscles. Like if you're just not used to that, and like, yeah, you're gonna start off not as strong. And that, like, yeah, that's why you see the pretty much that large increase in progress at the beginning, because like your brain adapts pretty quickly, or like the neurological changes happen pretty quickly, but then it tapers off because, like, yeah, your brain has done, you know, sufficient wiring at that point. I believe I've covered that principle before, but yeah, this paper I think is pretty interesting for a number of reasons. One, because, you know, it's in the category of anti-aging, and it shows a benefit for both resistance training and aerobic training. But also, it's interesting because it seems to focus on a very specific demographic, as in like their sample is literally just middle-aged Japanese women. Whether that's intentional or not, I don't know, or that's all they could have recruited for this study. But it's interesting that for a study focusing on aging skin, they just happen to only recruit women. But regardless, you know, this is just another potential benefit of exercise, both resistance training and aerobic exercise. And like, as they say here, exercise is a key strategy for achieving a longer, healthy lifespan because it has beneficial effects on physical and physiological health. For example, exercise is known to reverse age-related deterioration in neurogenesis and cognitive function in the brain, and improve stem cell function and muscular regeneration in muscle. However, the effects of exercise on skin aging are poorly understood. Although one study showed that aerobic exercise stimulates release of interleukin-15, which regulates skin aging by enhancing mitochondrial biogenesis in the skin. The skin is the largest organ in the body and acts as the primary barrier against infection and disease. Moreover, the skin constitutes neuroendocrine system. There's probably some sort of translation issue. I suspect this article was like written in Japanese and translated from Japanese. But yeah. Where was I? Yeah, the skin constitutes the neuroendocrine system. So the skin is not only the target of neuroendocrine factors, but also a source of hormones and neurotransmitters in response to extrinsic and local stress. Skin aging is associated with a deterioration in the dermis that results from the extracellular matrix degradation and is caused by extrinsic factors, such as sun exposure and air pollution. and intrinsic factors, such as age-related hormonal changes, neuroendocrine system, and increased levels of inflammatory cytokines. The cytokine changes are referred to as the senescence-associated secretory phenotype. In addition, dermal thickness decreases with aging and extracellular matrix degradation. Exercise training alters the circulating levels of cytokines and hormones, and these changes may be involved in the anti-aging effects of exercise. Recently, research has focused on myokines, cytokines produced by skeletal muscle cells that are often released into the circulation as mediators between exercise and various beneficial effects of exercise on health, because the secretion of myokines, including interleukin-15, is mainly induced by exercise. Interestingly, aerobic training and resistance training have different effects on circulating levels of various factors, and consequently, we hypothesize that they may have different effects on aging. Well, good question. I mean, I think there's some overlap of like, aging skin or skin aging, is arguably, your skin getting worse or bad over time. But what they're speaking here, or what they're talking about here, it's like, so we know exercise has various effects throughout the body, okay? Which I've already touched upon in terms of, physical health, mental health, brain health overall. But also, it has effects on the immune system, or, some sort of immune modulating effect. Generally speaking, benefits the immune system. And so what they talk about here on cytokines, okay, that they bring up, cytokines are chemical messengers of the immune system. There's a whole host of cytokines, but you can essentially think of them as the chemical messengers of the immune system. As in your immune system, is a very broad, or rather there's very many layers to the immune system. You have like your innate immunity, and then you have your adaptive immunity. Those are sort of like, generally speaking, the two major arms of the immune system. Kind of like, and like, for innate immunity, as the term implies, that's like more or less like sort of like built in, so to speak. As in, your skin is pretty much like, not pretty much, it is part of your innate immunity. As in, it's like the physical barrier, between, you and sort of like the outside world, or rather like, your skin, pretty much acts as a protective barrier against infection. And that, when your skin is broken or you have a cut, like, one of the primary concerns is infection. That's part of your innate immunity. As opposed to like your adaptive, that's, let's say that cell me, or like the one that is let's say trained. That's where, your antibody response is coming from. As in, when you get, or if you have received your SARS-CoV-2 vaccine, or your mRNA SARS-CoV-2 vaccine, it's like, oh, Zero, and welcome. Thank you so much for passing by. I'll get to your question in a moment. Just want to finish my thought. Yeah, your adaptive immune system, that's the one that's, generally like more targeted, or rather what they call cell-mediated, as in the part of the immune system that will, as the term implies, it will try to adapt or like target something. Where it's like, yeah, you receive the mRNA vaccine for SARS-CoV-2, you make the spike protein, and then your adaptive immune system makes the antibodies targeted against the spike protein. And so, exercise has, as they're outlining here, effects on these cytokines, as in, likely is having some sort of beneficial effects on the immune system. And then they bring up myokines, okay, and these are essentially, pretty much cytokines, but they're released from the muscle. As in cytokines produced by skeletal muscle cells. So they're still chemical messengers of the immune system, but just the origin is different. Although I don't want to get into the origins of like all cytokines, but they're still just chemical messengers of the immune system. So, that being said, what they're overall postulating here is like, well, if exercise is having this immune modulating effect, what some of the research shows is like, it overall has kind of like an anti-inflammatory effect. And part of that anti-inflammatory effect is likely coming from, its effects on cytokines or, other parts of the immune system. I'm sure there's a whole host of effects on the immune system coming from exercise. And so, as we're sort of going to see, that might be one of the reasons why they're observing this beneficial effect of exercise on the skin, or like skin aging. As in, if it has this overall broad anti-inflammatory effect, well, one of the things that, results in essentially your skin aging or, quote unquote, getting worse or bad over time, it's like, maybe too much inflammation or like an overall sort of elevated inflammatory state in the body, including the skin. And therefore, if you are reducing inflammation broadly overall through exercise, or maybe, more targeted, then it's like, you might just be in an overall less inflammatory state and thus less damage to your skin. But we'll see exactly what they say. So my views on omega-3s are I do supplement with omega-3, 6, and 9s. Although that's largely that is largely driven by the fact that, I follow a plant-based diet. And so, I'm just doing it sort of as, just to play it safe. Do I absolutely need it? And do I think I'm actually getting any sort of benefit from it? No. And the research, at least from the research that I've seen, there's nothing, there doesn't appear to be anything like dramatic so far about omega-3s. There might be some benefits, but so far, if there are benefits, there's nothing like world-changing. Fish oil is one of the main sources, but there are multiple sources of omega-3s. But yeah, that would be one of the most common ones. I have absolutely no idea who killed Tupac. I don't think anybody knows. That's my understanding. And yeah, it does seem like exercise helps with just about everything. And as mentioned before, I am listening. I am listening to this book, Outlive, by Peter Attia, or Attia, I don't know how to pronounce. I'm about like 60% through listening to it. They're pretty much one of their, one of the most emphasized recommendations in terms of like, what you can do for your longevity, is like, exercise. At least so far, which is like, no surprise. So far, I'm not really learning, all that much new from the book. I'm, getting a little bit more of the science behind it, but so far, all of the recommendations are pretty much all the things, mostly the things I'm already doing now, or that I already knew. I remember seeing a pretty extensive video from an eye doctor. Their journey with omega-3s. There were noted anecdotal benefits to eye health. So if they are deficient, if in fact, so I will fully admit, I don't know the stats on omega-3 deficiency. And on the topic of, anti-inflammatories, there is some research to show that maybe, doesn't need to be all that conclusive, but maybe some omega-3s or other omega-6s, omega-9s, or like some sort of like ratio might have some anti-inflammatory effect, or they might be important for, brain health, or heart health. But the research there seems to be pretty mixed, or again, pretty much either like no effect or like very mild to modest benefits so far. So like if you're willing to spend the money on omega-3s, it's almost certainly not going to do anything like negative. At most, you may just be wasting money. I think probably one of the best things. So I totally have. I had an article. I have this article. I guess I must have bookmarked it. Yes. That was published published just about 5 days ago, or exactly 5 days ago, about, maybe time to pay attention to COVID again. Because, again, I'm tracking a little bit of the numbers, and the new variants. Like, there does appear to be, a surge that is occurring. Totally. And that, like, I think people are ignoring, it to their detriment. Where was I? Yes. Therefore, to compare the effects of aerobic training and resistance training on skin aging, we performed a 16-week randomized study on 61 healthy, sedentary, middle-aged Japanese women and measured circulating levels of various factors in blood samples taken from participants before and after the training intervention. In parallel, plasma samples were added to normal human primary dermal fibroblasts. The expression of dermal extracellular matrix-related genes was quantified. So, what do they overall do? Well, I mean, they already shared that, you know, their sample population was like essentially middle-aged Japanese women. You know, very specific demographic. There's also a whole lot of denial on corporate broadcast saying get back to work. Yeah, totally. I mean, well, that's been happening for well over the past year. And it seems like, you know, more and more work from home is being phased out. Is this new variant associated with higher mortality rates? I haven't looked at. So I haven't looked into the mortality. At least not to any great depth. From what I can tell, it does not seem to result in, or rather doesn't appear to be, you know, more lethal or deadly than previous variants, at least from my very casual observations so far. But I probably should do a deep dive pretty soon to, you know, make sure that I'm actually have all the detailed information. But from most of the data I've seen, it's just like increases in hospitalization. But I don't know that it's translating into like the severe outcomes, like death. And yeah, totally, long COVID is a concern. And I totally have some research, newer research on long COVID, that I will probably have to dive into at some point. How does the body's adaptation to aerobic workouts differ between individuals of varying fitness levels? If I'm understanding your question correctly, Coffee, I think you're asking, well, ultimately, the answer is there's not that much variation in terms of like, someone who's, let's say, untrained or deconditioned, they will see adaptations do aerobic training or aerobic workouts. It's just like they will likely see some of the changes quicker, or rather the progress that someone makes when they go from, you know, deconditioned or untrained want to be faster than someone who is, you know, at a much higher fitness level. Like, you know, once you're sort of at the elite athlete or, you know, elite aerobic fitness, or like you're at elite level VO2 max, to make further progress in there is like, you know, quite a lot of effort and work. But basically to go from untrained or deconditioned to, let's just say, average or even to below average cardiorespiratory fitness, it actually doesn't take all that much. Or let's just say, I think you'll be pleasantly surprised if you start aerobic training or aerobic workouts, how quickly your body will adapt or the progress that you will make, provided you approach it and do it with an appropriate strategy. Where people, I think, generally speaking, start off with too much too soon, depending on the type of aerobic workout that you're doing. Let's just say taking running, for example, which is probably one of the more popular ones. People dive into running, I would say, too much too soon. And that if you want to take up pretty much just about any aerobic activity, if you want to achieve like health benefits, you should probably just focus on low impact, what they call like zone 2 cardiorespiratory training. Pretty much the aerobic workout that you're doing, the type of breathing that you are engaging in, you should essentially not be out of breath, or rather you should be able to like have more or less a casual conversation during your aerobic workout. Basically, you're not breathing to the point that it's a struggle for you to even just like speak. And as I've covered before, you don't need a lot of aerobic training to achieve the health benefits. As I've covered before, even just like 10-15 minutes a day, or like a few minutes spread out across the day, where you accumulate to like 15-20 minutes but in 2-minute intervals, that will also actually have some pretty significant benefits. So that's a good question. So what did they do for this study? So they did aerobic training and resistance training. They did a pre-measurement. They obviously, they basically established a baseline. And then 26 of the middle-aged Japanese women were aerobic training, and then 30 were resistance training, the middle-aged Japanese women. And then they did a post-measurement. Skin, pretty much, all of the baseline stuff that they took previously. Skin properties, body composition, physical capacity, blood sampling. They did it post measurement. And then they took blood samples, and they also they took some of the processed blood samples and added them to essentially some skin cells in a dish, and tried to determine like, well, is this kind of like rejuvenated blood having an effect on these skin cells, but specifically on the extracellular matrix. So yeah, 61 healthy, sedentary, well, maybe a little bit of an oxymoron, healthy, sedentary, but either way, middle-aged Japanese women. Their body weight and body mass index was measured. And what are the overall... I'm not going to analyze this data, because this is more or less... yeah. Looking at expression levels of certain genes in those cells in a dish. I should probably just go results by result. So, at baseline, no significant differences were found between the aerobic training and respiratory resistance training groups, in participant characteristics such as age, dietary intake, skin aging property, body composition, and physical capacity. The aerobic training intervention significantly decreased body weight and body mass index, and significantly improved peak oxygen uptake, or VO2 max, as a measure of aerobic capacity. And the resistance training intervention significantly increased lean soft tissue mass and 1 rep maximum as a measure of muscular strength, which is, no surprise. They're working with sedentary women, so going from sedentary to just about any activity, you will see pretty significant changes. And this was over 16 weeks, if I remember correctly. 16-week intervention. Skin elasticity and upper dermal structure, assessed as the rate of low echogenic pixels, improved significantly in both groups, and dermal thickness increased in the resistance training group. It was essentially, an increase in skin thickness in the resistance training group. Effects of blood plasma after aerobic training and resistance training on expression of dermal extracellular matrix related genes. So all that is to say is, like, they're asking the question of, so in aerobic training or resistance training, how is gene expression changing? Or rather, genes related specifically to the extracellular matrix. How is that changing? And I probably don't need to, I'm not going to dissect this, but pretty much there are changes in gene expression. No surprise. And specifically, changes in the gene expression associated or related to the extracellular matrix. Where it's like, after aerobic training, the expression of other collagen genes, both of the collagen genes, was increased. And after resistance training, the expression of proteoglycan-related genes, etc. All part of, the extracellular matrix of, dermal, or essentially like skin cells. So, circulating levels of various factors. What are the effects of aerobic training and resistance training? The circulating level of more than 1,480 factors, such as cytokines, serum hormones, and plasma metabolites, was measured in blood sampled before and after the training interventions. A number of circulating factors showed significant changes after the training interventions. In the aerobic training group, the circulating level of 28 factors increased, including myokines. So those chemical messengers of the immune system, but they are coming from the skeletal muscle, such as interleukin-15 and myonectin, and that of 41 factors decreased, including inflammatory factors such as interferon gamma and tumor necrosis related APOP, blah blah blah. So they're saying these things associated with inflammation. So these inflammatory factors, those were decreased as part of the 41 factors that decrease, including these inflammatory factors. So again, maybe highlighting the fact that maybe aerobic training or resistance training might have this, sort of broad anti-inflammatory effect, at least maybe over the long term. In the resistance training group, the circulating level of 34 factors increased, including myokines such as these ones and regulate on activation, blah blah blah. So normal T cell expressed and secreted increase. So again, some sort of immune modulating effect, or an effect on the immune system. And that of 27 factors decreased, again including inflammatory factors such as monocyte chemotactic protein 3 and CC motif chemokine ligand 28. All of these names aren't that super important. All that is just fancy terminology to say that these circulating things in your body associated with inflammation, some of those things like decreased. I'm not going to cover this. Inflammation factors affecting either. So, in this study, we showed that resistance training counteracts skin aging, such as deteriorations in skin elasticity, upper dermal structure, and dermal thickness. Our findings suggest that the increase in dermal thickness is a specific effect of resistance training on the skin and is induced by a decrease in circulating levels of CCL28 and N-dimethylglycine and CXCL4. They're pretty much saying, the dermal thickness, or this effect of increased dermal thickness, appears to be driven or associated with these circulating levels of these things. And an associated increase in dermal BGN expression. Aerobic training also had positive effects on skin elasticity and upper dermal structure, but it did not improve dermal thickness. Interesting. So even though it looks like there were beneficial effects of both aerobic training and resistance training, it seems like there was a unique effect of resistance training where that induced increased dermal thickness, like only in that group, only in the resistance training group. Aerobic training and resistance training have different physiological effects on the human body, and a meta-analysis indicated that resistance training promotes muscle hypertrophy more than aerobic training does. The present study also showed a significant increase in lean soft tissue mass and one repetition maximum in the resistance training group. Yeah, not surprising. Confirming that this resistance training intervention was effective. The increase in total lean soft tissue mass in the resistance training group was 0.44 kilograms. Basically gained about a pound, or like a pound and a half of lean soft tissue mass. Basically like a pound and a half, or a pound and a quarter of muscle. Corresponding to a rate of change of 1.2. The degree of muscle hypertrophy was reasonable for middle-aged participants because middle-aged individuals, 45 to 55 years of age, who undertook a 20-week resistance training program, experienced 1.1% increase in lean soft tissue mass. In the aerobic training group, we found a significant decrease in body weight and BMI and a significant increase in VO2 max. Which, yeah, that makes total sense. In that pretty much we generally only, or rather, yeah, you will generally only see like major increases in your VO2 max by engaging in aerobic training. The effects of resistance training or weight training on VO2 max is pretty negligible, or really, in my opinion, not all that significant. And VO2 max is like an important parameter of overall health, and especially overall health when it comes to longevity. Of like, if you can achieve or get to a point where you have a high VO2 max and you're able to maintain it for as long as possible, that appears to be associated with, let's just say healthy aging, or good longevity. That's also highlighted in the book that I'm listening to. And there is a little bit of an association, to actually accurately measure your VO2 max. You need to like go. You need to go to a facility and actually test that. Can't really get an accurate measure. With, let's say, on your own or without access to sophisticated equipment. But I think a decent, although imperfect, surrogate marker of VO2 max is resting heart rate. And that's something that I track. I think that's a pretty decent indicator of cardiorespiratory fitness. Where, like, yeah, speaking, the better your cardiorespiratory fitness, lower your resting heart rate. Although you can have a low resting heart rate for other reasons that are also indicators of, not good health, but, generally speaking, it's a decent marker. And like, yeah, if you don't have access to, or the ability to measure VO2 max, I think just like a heart rate monitor and measuring your resting heart rate is a pretty good indicator. And even I have some research demonstrating that resting heart rate seems to be a pretty good, pretty decent biomarker when it comes to sort of assessing your risk for all-cause mortality, which is one of the reasons why I track mine. On ab wheels, so at the end of the day, any exercise has value and utility. It's just a matter of what are your goals. Do I think ab wheels are like an efficient way to work your core? Not really. But, if you're, let's say, like a bodybuilder, or you want to like really develop your core, or you enjoy the movement. Some people, I'm sure, enjoy ab wheels. I don't particularly get much enjoyment from them. But if you enjoy the movement and you just also want to work your abs, then by all means go for it. But I would say you can totally get a good abdominal workout without an ab wheel, for sure, and that they are totally not necessary at all to develop your core or abdominal strength. But if you enjoy it, or if it's just something that you want something that's accessible at home, you enjoy it, go for it. I mean, there's depends on what you're. I assume you're largely talking about home workouts or things that are accessible at home. You can, I mean, your standard, although crunches and like sit-ups aren't really the best, but those are technically things that you could do. But there's planks, there's mountain climbers. If you have a pull-up bar, there's like leg raises, different varieties of leg raises. Uh, yeah, there's a whole host lab exercises. Although, you know, my question would be like, what is your goal in working abs? Because let's just say, if you just want to develop the strength in your abs, it's not a bad thing. But I would say, generally speaking, people focus too much on working their core. And like, let's just say it's, I don't know, unless like you're a bodybuilder or something, or like you're trying to do something specific with your core or your abdominals, you almost certainly should not have like a workout dedicated to just working out your abs. I more or less like put that in the accessory movement domain of like, if you're doing squats and deadlifts appropriately, you are working your abs. And if you're doing like other exercises or other compound movements appropriately, they're also an ab workout. If you engage in any running, that's also an ab workout. But I mostly work my abs as like, I work them, or rather I do like a couple ab exercises once or twice a week. But I never have like a workout devoted to just abs. I've never trained abs before, but I've got incredibly bad ab genetics, so I thought I'd start doing something. But at the end of my pull day, I do a couple of ab rolls. So I'm assuming when you say you've been really feeling them, you're feeling them in a good way, as in if you enjoy it, great. Just also bear in mind, like, if your actual goal is like, whatever, 6-pack abs, or like, visual, or yeah, visibly apparent abdominal muscle, that's really not you are not going to get that much benefit to just like focusing on ab workouts and like getting visible abs is largely diet and exercise, or rather diet and burning calories, or pretty much losing body fat, getting to the point that you're lean such that they're visible. Although I'm not saying that's necessarily like a good goal, but if that's your goal, that would be the way to do it. But it's absolutely not bad to work your abs. But it's unlikely that you need a day dedicated to just working your abs. And the strategy that you're employing now is probably just fine. Of like, if you're just working it in a couple of ab exercises at the end of your primary workout, totally fine. Well, so how do you know that you've gotten lean is the question. Because, well, first of all, where people, lose fat from their bodies, that's going to be unique to the individual. Generally speaking, for men, the last place, or one of the last places where fat is removed from their body, or like their fat cells shrink, is going to be sort of in the torso or the abdominal area. So it's like, you might think you're lean because like, yeah, your arms and legs and shoulders are lean, but really you might just have stored fat in your torso or abdominal area, just because like that's the last place. But like, yeah, if you're getting your body fat assessed through, let's say, a DEXA scan, and they're saying, oh yeah, you're like whatever 8 or 7% body fat and you still don't have abs, then maybe ab exercises would be beneficial to you. But I don't think that is the case. And even then, a DEXA scan isn't. There's also some error associated with getting your body fat measured with that. At the end of the day, I don't think there's any really highly accurate way to assess accurately your body fat percent. And yeah, if you just want abs for the sake of abs, like, I mean, go for it, but I would say it's not necessary. Or rather, it's like overrated, or there's nothing special about it. Not gonna change your life. Take it from someone who is lean. There's nothing. I mean, I maintain, you know, a lean physique just because I like to be functional, and all that stuff. But it's I'm not doing that with that much like intention. I'm just like so physically active, and you know, have an overall pretty healthy diet, not perfect, that it just happens to work out. But there's nothing special about having abs. Yeah. And there's, yeah, I would say, like I said, there's, unless you're a bodybuilder, you don't get much utility out of like specifically training abs or like doing like 6 ab exercises in one session. I've never gotten like lean, but definitely to a level of lean where most have visible abs. Even then, it's hard to say because like it may not be, you know, bad ab genetics. It might just be that, you know, due to your genetic background, that like, yeah, you know, the last stores of fat are just like contained in your abdominal or your core or your torso area. Like I've seen people, you know, with abs that don't look all that lean. Or rather, like, you know, they clearly have fat in other areas of their bodies, like their muscles and their shoulders and their chest. But, you know, due to their genetic background, they just happen to lose fat quicker in their abdominal or torso area. So, like, yeah, they'll get abs, but then, like, their shoulder definition will be, you know, a little bit different than their abdominal definition. Yeah, where was I? Yes. Yeah, the VO2 max, yeah, this aspect of resistance training, resulting in increased skin thickness. And then, yeah, aerobic training, you don't see this increase in skin thickness. But, like, yeah, you see, but there's still benefits, clearly, benefits to aerobic training. As they say, there's the benefits of increase in VO2 max. They have a significant decrease in body weight and BMI. It's just like, and there's still benefits, or at least there appears to be still benefits to, let's say, skin, or, you know, this anti-aging aspect, or rejuvenating the skin. Just that that dermal thickness aspect doesn't appear to be there for aerobic training. A comparison of aerobic training and resistance training based on the hypothesis that the two types of training have different effects on the skin showed that resistance training specifically increased dermal thickness, which is known to decrease with aging. Increased dermal thickness, which is right. Okay, yeah. So essentially, well, yeah, I already knew that, but there appears to be this thinning of the skin as you age, and that, like, yeah, resistance training might counteract that, or even, like, you know, reverse that. In addition, both aerobic training and resistance training showed some rejuvenating effects on the skin, such as improving elasticity and upper dermal structure by inducing an increase in dermal extracellular matrices. Elasticity is a general physical property of skin that is known to decrease with aging, and the rate of LEP, the upper dermal layer, what is, remember, oh, the low echogenic pixels. Yeah, and the rate of low ecogenic pixels in the upper dermal layer is reported to increase with aging, generating the low ecogenic area at the upper dermis called the aging band, or subepidermal low ecogenic band. Both skin elasticity and upper dermal structure deteriorate because of not only aging, but also sun exposure, and changes in both are thought to be related to a decrease in dermal extracellular matrices. In fact, the extracellular matrix is suggested to be related to the elastic property and ultrasound ecogenicity of the dermis. Some people have insane abgenetics. They clearly got it. Yeah. I mean, if you look at a lot of the strongman competitors, although they're not a realistic standard to look at because, you know, they're on all kinds of substances. But if you look at someone like, you know, even like Eddie Hall, you know, world's strongest man. Like, I think he currently has abs, but I don't think his body fat percentage is all that low. I think he just has like such high development of, you know, his core and also just like his torso. Well, I think there have been some clear sort of physiological changes that have happened as a result of not only the type of training that he does, but I think of presumably all the substances that he takes. That, like, yeah, can have visible abs, but still have a pretty reasonably high levels of body fat. And even then, I think on someone like Eddie Hall, it looks a little bit strange, or like, you know, it almost looks, in my mind, out of place, because like everything else that I see would sort of indicate that, yeah, like, yeah, this person would not have abs, and like, yeah, they appear to be there, but even then, they look a little bit strange. Yeah, it is strange. In aged mice, exercise increased neurogenesis. So this is, you know, as the term implies, you know, the generation of new neurons in the brain, and cognitive function. But this is in mice, but, you know, it's generally thought that the same thing holds true in humans, even though I've shared research recently that maybe calls into question or, you know, highlights that some of the research on the benefits of exercise, you know, might not be of the highest quality. But that's not to say, or at least the research demonstrating the cognitive benefits of exercise may not be of the highest quality. But that's not to say that there is no benefit. And glycophosphatidylanisotal, specific phospholipase D1, was identified as an exercise-induced liver-derived circulating factor that was sufficient to improve hippocampal function. All that to say is, you know, this thing, GPI, appears to be increased as a result of exercise, and then this as a result of that increase, it appears to have a positive benefit or improve hippocampal function, which is the hippocampus. That is the area of the brain largely responsible for memory formation or the storage of memories. Regarding the skin, aerobic exercise was reported to stimulate mitochondrial biogenesis in fibroblasts and increase dermal collagen content. And IL-15 was identified as the muscle drive mediator of these effects. So yeah, aerobic exercise. So they're saying that. So I think virtually everyone now knows that mitochondria are is the powerhouse of the cell, and that's where energy is produced, or specifically energy in the form of ATP is produced. Location of cellular respiration. And yeah, they're essentially saying that aerobic exercise stimulated the genesis or the creation of new mitochondria, or, you know, technical terminology, mitochondrial biogenesis, in those skin fibroblasts. So, you know, let's just say the energy metabolism of these skin fibroblasts appears to be altered. And that appears to be just an overall adaptation of aerobic exercise, of just like multiple adaptations to your mitochondria. Not only just to the mitochondria themselves, but also the generation of new mitochondria. And yeah, increased dermal collagen content. And collagen is like one of the main structural proteins of the skin. And IL-15 was identified as the muscle dry mediator of these. Yeah, right. Our study also found that aerobic training increased the circulating level of IL-15 and improved dermal structure. So in this IL-15, that is a cytokine. So again, having the exercise, in this case aerobic training, is having some sort of effect on the immune system, or this chemical messenger. In this study, we found that the expression of major collagen fibril genes, such as COL1A2 and COL3A1, and proteoglycan genes, such as these ones, was increased after both interventions. These results suggest that training-induced changes in circulating factors increase numerous components of the dermal extracellular matrix, leading to improvements in skin elasticity and upper dermal structure. After the resistance training intervention, dermal thickness and expression levels of BGN and CHSY1 increased. The relationship between CHSY1 and dermal thickness is unclear, but BGN knockout mice were reported to show a thinned dermis phenotype. So this is to say that when this BGN gene, was knocked out, as in pretty much, you can think of it as this mice, doesn't have this gene. And so, well, I mean, that's sort of one of the standard ways, or conventional ways, trying to tease out the function of a gene. Of like, hey, how about we just remove it or knock it out and observe, the effect on the animal, in this case, a mouse. And so they're saying, well, we basically removed this gene or knocked it out in the mice, and it resulted in basically thinner skin phenotype. So presumably, or the general conclusion would be that this gene, this BGN gene, appears to play a role in dermal thickness or skin thickness, because when they removed it, it appeared like the skin got thinner of the mice. And biglycan levels were found to decrease with aging and sun exposure. Taken together, these findings suggest that increased BGN expression could lead to increased dermal thickness, right? And that's why they're coming to this conclusion of like, well, when we remove the gene from these mice, their skin got thinner, and we're seeing that exercise is increasing the expression of this gene, this BGN gene, and we appear to be observing this increase in dermal thickness or skin thickness. And so, pretty decent amount of confidence that this gene, this BGN gene, is playing some sort of role in dermal thickness, or skin thickness. Is it collagen type 2? I don't think they specify the type of collagen. It is a valid question. Moreover, the present study, I'm not sure that they would have the tools, per se, to identify the type of collagen. I need to refresh my brain. One second. So yeah, it's a totally valid question because, as highlighted, there are different types of collagen. So yeah, you asked about type 2, an elastic cartilage, which provide joint support. So they would probably have to, given the fact that, yeah, it seems like the collagen or the types of collagen is separated by location. Although type 1 makes up 90% of your body's collagen, but you have like type 2 seems to be largely in the joint, type 3 muscles, arteries, and organs. So yeah, they would probably have to, what they would need to do in order to assess, whether it's changing the type, they'd probably be like pretty invasive, or they would need to like trace, yeah, which specific genes associated. But they do, the CCL28, those are almost certainly to do with collagen, or at least this col3A. Okay, they do talk about it here. So yeah, this col3A, collagen type 3, alpha 1 chain, collagen type 1. So it seems like at least multiple forms of collagen are affected. Which, yeah, that makes sense given the fact that there were effects on gene expression for a variety, well, pretty much collagen encoding genes, multiple collagen encoding genes were affected by the exercise intervention. Where was I? I was right. Oh yeah, here. Moreover, the present study identified circulating, well, pretty much all of the changes in gene expression, which I don't necessarily want to dissect. The circulating level of inflammatory factors is speculated to be enhanced by factors including aging, stress, and physical inactivity. In contrast, aerobic exercise is an effective strategy to reduce circulating inflammatory factors. So yeah, that's more or less what I tried to highlight earlier. Of like, you know, even though past research has shown this, this is just like adding on to the current body of research, and maybe expanding of like, well, how far does this anti-inflammatory effect go? Where it's like, is it also, given the fact that, you know, inflammation, or like broad inflammation throughout the body, or being in an overall inflammatory state, it will have detrimental effects on the skin over time. And so if exercise has this, you know, broad anti-inflammatory effect, or at least, you know, leaning towards anti-inflammatory effect broadly, well then yeah, then you might be kind of reversing or preventing that inflammatory damage to the skin over time as you age. Although inflammation, you know, yeah, I don't really like talking about inflammation because there's a lot of nuance where, you know, extreme anti-inflammatory, not necessarily good. Like there's a time and place for inflammation, as in inflammation is, you know, a normal part of the physiological processes in your body. Arguably, you know, when you actually exercise, in the moment that you are exercising, that is an inflammatory induced condition. It's also a stress induced condition, but it's the after effects. It's all the physiological adaptations that occur afterwards that, you know, might promote an anti-inflammatory effect. So yeah. In contrast, I already read that. So taken together, the results of the present study suggest that not only aerobic training, but also resistance training attenuates the circulating level of inflammatory factors and improves dermal aging. In particular, the results indicate that resistance training increases the thinning dermis and simultaneously reduces circulating levels of CCL28 and CXCL4, which were identified as key inflammatory factors that suppress the expression of BGN, thereby helping to improve the thickness of the dermis. But here is limitation that our conclusion is considered by the following three separate results. Resistance training increased dermal thickness. 2. Blood plasma after resistance training increased BGN relating to dermal thickness. And 3. Circulating inflammatory factors reduced by resistance training suppressed BGN gene expression. Therefore, more direct animal studies modulating circulating inflammatory factors are needed to clearly confirm the skin rejuvenating mechanism of resistance training. You know, all that to say, it's like there are still some unanswered questions of like, what exactly is going on? They're observing this effect, but they're not certain the exact causal mechanism that is driving this skin rejuvenating effect. Pretty much, to be more specific, the exact mechanism. They're sort of pointing to some suspects in terms of like BGN gene expression, and maybe overall promoting an anti-inflammatory state, but they still can't pinpoint of like, hey, these are the exact molecular mechanisms or molecular players that are having this effect, because that's very difficult to determine in humans or even in animals in general. In conclusion, a 16-week intervention with aerobic training and resistance training showed that both training interventions counteract skin aging by improving skin elasticity and upper dermal structure. In addition, resistance training increases dermal thickness by inducing a reduction in circulating levels of CCL28, N-dimethylglycine, and CXCL4, and thus suppressing expression of dermal BGN. The study clarified only the mechanism by which resistance training counteracts age-associated dermal thinning, and the other mechanisms of aerobic training and resistance training driven skin rejuvenation remain to be elucidated. Pretty much, they're only really able to hone in on like one specific thing, or not one, but like one of the primary things. It's like, okay, resistance training appears to be having a specific effect of like increased dermal thickness or increased skin thickness, and they were able to tease out, or like more accurately pinpoint, of like it's this aspect of BGN, or rather BGN expression, that is driving the increased dermal thickness that is happening with resistance training. And like, yeah, as I highlighted, this is a very specific sample population where, yeah, this is Japanese women aged 41 to 59 years living in Japan. They were, yeah, sedentary. So, even then, there's a little bit of a caveat, or like, a grain of salt to be taken of like, does this, since they only looked at middle-aged Japanese sedentary women, and you extrapolate it to all humans worldwide, probably not. I mean, maybe you can, but let's just say, I would say it's not a high degree of confidence. Like, this is, I think, a clear limitation of this study, of like what they're observing here may very well just be isolated to middle-aged sedentary Japanese women aged 41 to 59 living in Japan. And that, they might, if they want to maybe extrapolate more broadly to the population at large, they probably need to diversify their sample, their population sample. So that's the end of it. Pretty brief. Well, that's the nature of scientific reports. They're fairly brief studies. I think there's actually a page limit when you publish this journal. I think it's like 5 or 6 pages in total. But either way, I still think pretty cool. And I think is, a potential further testament to the effects of exercise. Although, how important is it to maintain, your skin rejuvenation, or, the youth of your skin as you age? I don't know. Maybe not super critical. But even then, we're seeing that, as they say, there's this kind of like overall promotion of an anti-inflammatory state as a result of exercise. And that, this effect on the skin might be kind of like a side effect. But yeah, overall further testament to the overall anti-aging aspects of exercise. And that, promoting healthy aging, or to increase the chances that you age healthily. Incorporating some sort of movement or exercise is almost certainly a good thing, or almost universally a good thing. And then I'm probably gonna save this for maybe tomorrow's stream, or maybe next week. I also have more research on exercise, maybe going the opposite direction, where going from middle-aged Japanese women, we go to healthy young men. But this is like, so, many people are concerned that, you know, if you're not getting enough sleep, that, you know, that might affect, you know, your ability to build muscle and strength. And this research seems to kind of point to that, well, that might not be the case, as in you might be able to get away with sleep deprivation or some amount of sleep deprivation and have minimal effect on your ability to build strength and or muscle. But this is in healthy young men, so again, this might not be able, you may not be able to extrapolate to the global population. But yeah, just something that I'm almost certainly going to cover on a future stream. But yeah, I totally thought of you when I came across this. Because I mean, it's in the title: the effect of sleep restriction with or without high intensity interval exercise on myofibrillar protein synthesis in healthy young men. So it's not talking about strength training per se. But yeah, those are the key points. Sleep restriction has previously been associated with the loss of muscle mass in both human and animal models. But as they're sort of, they try out sleep restriction here, and it seems like you might be able to get away with some sleep restriction, but, you know, but also bear in mind they're looking at a very specific thing, as in just because it may have a negligible or not super significant effect on your ability to build strength and muscle, you know, I think it's fair to say at this point that, you know, sleep restriction or sleep deprivation not conducive to your overall health or longevity. Where I would like, but I understand. You're a student, and like, I know the student life, but just be aware. Like, yeah, you can have some confidence that maybe might not affect your gains in the gym, but there's still a whole mountain of evidence showing that sleep restriction in the long run doesn't appear to be the greatest for your overall health or your overall brain health. But yeah, moving on to the second topic I want to cover. And this pretty much, I think, follows nicely exactly what I was talking about yesterday. Or what we very briefly touched upon yesterday with the microbiome. And I brought up the fact that there's probably some sort of capsule or some sort of like swallowable or ingestible device that will have the ability to like maybe not only take like biopsies, but take samples of your microbiome. And it seems like this research published like 3 months ago, like exactly that. I think it's pretty cool. And I haven't read this study yet. It seems pretty long, although I think most of it is methodology and like, you know, all the data associated with their microbiome sampling that they're doing. I'm not going to dissect that. That is not my wheelhouse. But pretty much my first reading of the studies. I'm probably going to be stumbling through. Because I literally just found it a few hours before stream. Because it just kind of crossed my mind of like, oh, did what I say yesterday, you know, did I just like pull that out of thin air, or is there any element of truth to that? Turns out there is. So, the human intestinal tract harbors the vast majority of microorganisms residing in or on our bodies. Their genetic content and biochemical transformation capabilities are hundreds of times larger than those encoded by the human genome. Humans depend on their gut microorganisms for food digestion, immune system regulation, and protection against pathogens, among other critical functions. An important yet often overlooked aspect of the gut is regional heterogeneity and how it impacts local physiology. Good question. I think they trialed this in humans, right? Because it's in the title, and like, what they highlight, I very briefly like did a perusing of the article, and one things they touch upon, it's like, well, there are clear current challenges with characterizing the human microbiome. Of like, yeah, we generally just go by, human waste output, stool samples. We kind of like use that as a proxy of like, well, if it's in your human waste output, that's probably what's in, your large intestine, generally speaking. Or it's like maybe somewhere in your GI tract. But there's research to show that, there are very clear shortcomings to like relying on stool samples for trying to characterize the microbiome. One is that, yeah, like what's in your human waste is not necessarily reflective of what's actually inside your intestines. And also, as things pass through your gastrointestinal tract, there's almost like an entire metabolism, or like arguably like a second metabolism in your gut, your GI tract, of like as things pass through, things are chemically modified, new things are produced, treated, other things are like degraded, etc., etc. There's an infinite number of things going on. And so it's like, we're kind of like seeing the end product when we're analyzing the output of the human waste, the stool sample, where for the, like, we're pretty much seeing all the end products of like all of the metabolism and all the stuff that has occurred in your GI tract, and we're trying to like draw conclusions from there, as opposed to like, as I highlighted earlier, not earlier, but yesterday, with the research that I went over with the engineered bacteria. Well, they were talking about, the engineered bacteria. One of it was engineered to take up and recognize cancerous DNA. And what they say, it's like, well, why can't we just analyze the DNA from a stool sample? Well, as they highlight, in your GI tract, or pretty much like in your intestines, like if there's any DNA there, the longer it's sitting there, the greater the likelihood that's going to be degraded. As in, I think, actually that springboards nicely from yesterday, of like, if you were to go by stool sample alone, you would think that, there's no DNA in your GI tract. But we know that there is DNA in your GI tract. It just happens to be degraded. And it's degraded before you would potentially expel it in your waste. And that's why, like, one of the key advantages of the engineered bacteria, it's like, well, it's supposed to be designed to be in your GI tract, or like in your large intestine in the case of colorectal cancer. And then like once the DNA is like, shed or released from, the cancer cell or the tumor cell, well, then it's immediately taken up, or, it's very, very quickly taken up by the engineered biosensor bacteria. And once it's taken up by the bacteria, it should be protected from all of the DNA degrading stuff that's contained in your intestines. And so the same sort of like logic holds here with some of the challenges in characterizing the microbiome. Of like, there's a lot of stuff going on, a lot of like metabolic products being produced, degraded, and so yeah, it's pretty much not accurate to rely on, our waste products. Let's hope they implement. Well, first of all, you already had like the upper endoscopy, like you survived that. The lower one, like, not that big of a deal. I mean, at the end of the day, let's hope that you don't need one until, it's recommended by the guidelines that you start screening for it. But given the fact that they're using actual human people here, this is probably not too far off. I don't know about like next year, but it seems realistic to think that given that they're already at the level of humans, probably in like 5-10 years. So an important yet often overlooked aspect of the gut is regional heterogeneity and how it impacts the local physiology. Because of difficulties in accessing and sampling the intestinal tract, stool has been the main source of information for human gut microbiome studies, right? And that's also what I wanted to highlight. Of like, okay, given all of these challenges or all of these shortcomings associated with using the stool, the human waste products to characterize the human microbiome. Well, then there are studies that use mice, and like they characterize the microbiome of mice, and then they try to extrapolate it to humans, or like apply it to humans, or like maybe this is what is going on to humans. But there are obviously clear shortcomings of that, where it's we can either do like an in-depth analysis of a mouse, and then there's the obvious problems of like we're using mice to try to understand what's going on with humans, or we use what humans produce, their waste products, and try to apply it to them, but there are clear shortcomings with there because as they say here, it's like there's a whole bunch of stuff that we are missing. However, stool reflects waste products and downstream effluent, within which regional variation is lost, right? As we're not actually sampling at the actual location. For example, key metabolites such as bile acids are altered upstream by microbial transformations and then substantially absorbed by the host before excretion. The regions of the gut distal to the stomach, distal is just fancy terminology for like downstream too, or like after stomach. The duodenum, jejunum, ileum, and colon. So yeah, these three: small intestine, colon, large intestine. Differ markedly in nutrient availability, pH, oxygen partial pressure, mucosal structure, and flow rate. As a result, distinct microbial communities with specialized functions, metabolomes, immune niches, and proteomes are present in each intestinal region. Thus, deeper understanding of how gut microorganisms impact human physiology and vice versa requires local sampling of the gut microbiome and its chemical environment in natural, unperturbed states. Historically, sampling the human intestinal tract without disturbance or contamination has been challenging. Right. We recently discovered substantial regional variability in microbiota composition across spatial scales of only a few inches throughout the intestines of deceased organ donors. However, organ donors have typically been treated with antibiotics, and even in cases in which the intestinal tract has been sampled immediately after cessation of life support, the gut is often ischemic or necrotic. Right. So this is scientists trying to address some of the technical challenges in trying to characterize the human microbiome. As they sort of say, there's basically pros and cons to all of the methods that we've tried so far. Like, yeah, as highlighted, we sometimes use mouse models or other animal models, but given the fact that they're other animals, it might not apply to humans. There's the highlighted shortcoming of using stool samples. We're missing a bunch of stuff. And then they're actually saying that, well, we've looked at actual, like, basically cadavers or people that have passed away, but it often happens that, people that they're essentially, dissecting, that have unfortunately passed away, that are now cadavers, they have been treated with antibiotics, and if they've been treated with antibiotics, well, then that will almost certainly alter their gut microbiome. And then also, even if they haven't been treated with antibiotics, as they say, the gut is often basically not in a good state once they've been taken off of life support. Either like ischemic or necrotic, or pretty much in the process of, dying. And so that will change the local environment of the gut and will thus almost certainly change the gut microbiome of that particular person. So, duodenal or duodenal sampling from live individuals using upper endoscopy has a high probability of inadvertent contamination from oral, esophageal, or gastric contents, right? So, well, Bob Marley, I think recently just had an upper endoscopy, so they could technically sample the earlier parts of your small intestine, but they have to actually go in with a scope, or the fancy tubing with the camera at the end, or with whatever sampling arm. But even then, like, once, if they actually like go in manually, it has to go in the reverse direction. And as it goes in the reverse direction, there's almost certainly going to be some contamination. As in, like, get to the early parts of the small intestine, well, you have to go through the esophagus. You have to go through the stomach. And then, like, once you go on the reverse, you're going to encounter the stomach again. You're going to encounter the esophagus again. And that will likely contaminate, the instrumentation. And then, introduce something into your samples that you probably don't want there, that will end up in the data. So, endoscopic access to the mid-jejunum requires a 2-hour procedure involving general anesthesia or sedation performed under fasting. Right. So it's like, pretty much, the deeper you want to go into, the small intestine, obviously, like, the more invasive or the more intensive the procedure. Alternatively, a stoma from exteriorization of the ileum through the abdominal wall can provide intestinal samples, but this procedure is invasive and reflects altered gut anatomy and physiology at a single location. Right. So, some people, even some individuals or patients with Crohn's disease or ulcerative colitis, they have had their entire large intestine removed, or large intestine and portions of their small intestine removed, and, like, actually part of their intestine is essentially connected to, like, their abdominal wall, as in, like, they are passing waste through their abdominal cavity. But there's essentially a bag, a stoma bag, that collects the waste that they're now essentially going to the bathroom, and they have to, like, manually empty the bag that is collecting the waste. So, like, technically, yeah, you can, like, sample the microbiome to patients that have had this procedure. But, understandably, they have a very unique gastrointestinal system. And so it's like, whatever you're finding there, almost certainly not extrapolatable to the population at large. And yeah, as they say, still an invasive procedure. Despite the important effects on the microbiome and signaling properties of bile acids, studies on their chemical diversity and concentrations have relied on non-representative measurements of the few percent of bile acids in stool or the fraction of a percent in blood. Previously developed ingestible devices for sampling the human intestinal tract have important limitations, such as complex electronics, large size that risks device retention, or insufficient sampling volume for multi-omics analyses. pH profiles, peristalsis, diet, physiology, gastrointestinal disorders, and key metabolites such as bile acids differ markedly between humans and animals, making human studies most relevant to human physiology and disease. Right. Where, if we want to understand humans, well, then we want to work with humans. To measure microbial, viral, proteomic, and bile acid profiles within the human intestines during normal digestion, we developed and evaluated a capsule device that collects luminal contents from the small intestine or ascending colon. Right, so that's literally what I mentioned yesterday. Like, capsule endoscopy is a thing. And, it's basically a pill camera, or a camera in pill form. And, it's used to essentially visualize parts of the GI tract. Or as they say here, see inside your small intestine, an area that isn't easily reached with more traditional endoscopy procedures. So it's like, yeah, we can now access it, or access, your small intestine, but we can only access it visually, as in literally just a camera. We're taking pictures, or like taking video recording. So, like, you can't actually take a sample. like with this research, they're trying to essentially expand or make this technology better. Of like, hey, ideally we want to like take some sort of sample. The expanding bladder and lack of internal structure in our device allowed approximately 400 microliters of liquid to be retrieved, enabling multi-omic analyses. So 400 microliters, so 1,000 microliters is 1 milliliter. So, you know, technically 400 microliters, that is 0.4 milliliters. But you can roughly think of it as like half of a milliliter, you know, rounding up 500 microliters. That is like roughly, I mean, it's like less than like a thimbleful. Like, it's a very small amount. It's like, you know, 4 to 5 raindrops of liquid. Basically not that much, if you know how much 1 milliliter of liquid. We report differences in microbiome composition, gene class abundance, prophage induction, and the host proteome between the intestines and stool. We discovered gradients of microbially transformed bile acids along the intestinal tract and identified correlations between the abundance of microbially modified bile acids and specific gut bacterial species. In a separate manuscript, we combined 5 metabolomics assays to identify spatial and temporal differences between stool and intestinal metabolomes, including diet-derived compounds and microbially linked metabolites such as sulfonolipids and fatty acid esters of hydroxy fatty acid lipids. These discoveries illuminate biological properties of the intestinal tract that are inaccessible from stool or endoscopic sampling. So, what is their actual device? Second. The sampling capsule is a single use, thankfully. I don't know that anybody would be comfortable, you know, using a secondhand device after it's been like, after it's passed through someone else's entire GI tract, and, you know, expelled in their waste, and then, you know, fished out of, I guess, their toilet or something. Even though you probably, well, actually, I couldn't disinfect this with the technology surviving, probably. But yeah, single use, passive device that collects fluid from the human intestines for ex vivo analysis. Right, so it's pretty much basically taking liquid samples as it passes through, and then, you know, whatever, the researchers extract that small amount of liquid and they analyze it to characterize the microbiome. The device contains a collapsed collection bladder capped by a one-way valve inside a dissolvable capsule with an enteric coating. Figure 1A. But yeah, right here. Oh, we'll return to this. The enteric coating prevents contact between the collection bladder and the surrounding environment before entry into the intestines. The pH of the intestines typically rises from 4 to 6 in the duodenum to 7, 8 in the ileum. Once the device reaches a preset pH sufficient to dissolve the enteric coating, the collection bladder expands and draws in luminal contents through the one-way valve. Right, so they are essentially taking advantage or exploiting the fact that, you know, as you pass through your GI tract, there are local changes in the pH, as in, like, as they sort of say here, in this particular region in your small intestine, pH is like 4 to 6. But then once you get further into your small intestine, so the ileum, that's essentially the last portion of your small intestine, the pH rises, essentially gets more basic, into about the 7 or 8 range. And you can actually, well, they've actually designed their capsule, but even medications on the market now exploit this fact of these local changes in pH, because sometimes you only want a medication released in a specific portion in the GI tract, or you don't want it to dissolve in the stomach. So they'll design medications that can, withstand the conditions in your stomach, and only once it reaches, the particular region in your GI tract that has that particular pH will, pretty much the medication dissolve, or the outer coating of the medication will dissolve and will release, the actual medication. It seems like they're exploiting this aspect here with their fancy camera pill, because like, yeah, they don't necessarily want samples, from the esophagus or like from the stomach. Those are probably, or they can be more realistically reached through, the conventional methods like endoscopy or upper endoscopy. And it seems like they're largely interested, understandably, with accessing the largely inaccessible areas of the small intestine. And so that's why they pretty much only want it released, or they only wanted to start sampling once it gets into their regions of interest. So, to sample from 4 distinct regions of the intestinal tract, 4 devices were ingested as a set after an individual ate a meal of their choosing, wherein different device types in a set were designed to open at different, progressively higher pH levels. Okay, so interesting. Not just one camera pill or capsule that they're ingesting. There's 4, which makes sense. To kind of exploit the fact that, hey, this capsule releases here at this region, start sampling, and then this other capsule releases here, sampling. Device type 4 included a time delay coating to bias collection towards the ascending colon, where the pH typically drops relative to the terminal ileum. Each device collects up to 400 microliters of luminal contents. Bacterial density is higher in the lumen than at or within the mucosa. Most mucosa-associated bacteria are represented in the luminal contents, and many metabolites of interest are in the lumen. After the bladder fills, the one-way valve prevents further entrance of liquid. The ingested devices are recovered from stool, and collected samples are extracted for analysis. These devices provide unique potential for multi-region collection of microorganisms and metabolites within the intestines during normal digestion. So, super cool, although we're gonna take a little bit of a closer look. But yeah, it seems like, 1 second. Yeah, it seems like, basically, they're collecting liquid, and, let's just say the ultimate end goal, and maybe this is where, might be bad news for you, Bob Marley, if you're relying on this technology, or this specific technology, to make it to humans, before you require, an endoscopy, or a lower endoscopy, because it looks like they're sampling liquid, and like understandably doesn't have the ability to take biopsies, or like actually take tissue samples of like, hey, here's a tiny portion of like the lining of the intestine, which is what you ideally want to look at. You're doing an endoscopy. So really this seems largely customized, at least so far. Maybe I might change my tune tomorrow. Or like maybe another capsule is being developed that actually can sample and take like a tissue biopsy. This seems essentially specifically targeted to be able to collect liquid samples to characterize the microbiome. We first sought to confirm whether the devices could be targeted to specific intestinal locations and would progress through the intestinal tract without contamination. In a feasibility study, we connected devices targeting the jejunum and ascending colon to a capsule endoscope and visualized successful in vivo sampling in a human. And it looks like there's videos. I don't have access to that. To assess potential effects of incubation of the collected microorganisms in the device while it transited through the gut, we retrieved and incubated a set of 4 devices from a single bowel movement in an anaerobic chamber at 37 degrees for up to 87 hours. We found that major changes in microbiota composition did not occur in devices with a transit incubation time of 58 hours or less. Within these experimental limitations, we demonstrate below that microorganisms and metabolites display longitudinal gradients along the intestine and are highly distinct from the contents of stool samples. Okay. Interesting. So, second. They are trying to, or it looks like they're trying to control for certain aspects of, like, as highlighted earlier, you know, one of the more conventional methods of trying to characterize the microbiome is, like, taking samples from stool, which has some obvious shortcomings of, like, hey, basically a lot of stuff missing. And now here, what they appear to be saying is, like, as the capsule, passes through the GI tract, there's this time aspect of, like, that takes time. And maybe as it's, like, passing through and sampling, over the course of, hours or dozens of hours, maybe, the liquid samples that are collected, maybe those are undergoing, changes, and it's not actually reflective of, like, what's actually happening, at the site sampling. So to sort of control for that, or to assess if that's actually true, sort of, like, basically, as they put it, incubation time. Like, as the person has, swallowed these capsules, it's essentially incubating inside them as it's collecting samples. And so they're trying to see, like, well, does incubation time actually affect what's going on in the liquid samples that they're collecting? So they run this kind of, like, experiment of, like, we retrieved and incubated a set of 4 devices from a single bowel movement in an anaerobic chamber at 37 degrees Celsius for up to 87 hours. So, they took some of the devices that passed through, and they just, like, let them sit in, basically human temperature conditions. And then they probably sampled them regularly, like every hour, or some sort of time interval. Be like, hey, at what point of, like, of when they're just sitting there under human temperature conditions do we start to see, like, changes are occurring, of, like, hey, at times equal to 1, this is what the microbiome looks like, and then at time is equal to 58 hours, like, they're cut off, or, like, hey, after 58 hours, what we saw at time 0 is no longer the same after, like, 59 hours, as in something is happening to the samples when they're just sitting there after 58 hours, or approximately 58 hours. But yeah, within these experimental limitations, we demonstrate below that microorganisms and metabolites display longitudinal gradients along the intestine and are highly distinct from the contents of stool samples. They're also highlighting the fact that, well, as we sort of already knew, highlighted, that, yeah, there's clear shortcomings, and that they've confirmed that, like, relying on stool samples, not all that accurate, as, like, they're getting something almost certainly significantly or dramatically different. To assess compositional and functional differences within the intestinal microbiome, we carried out a clinical study with 15 healthy human participants. First, a single device was swallowed and retrieved to ensure that no complications arose during passage through the gut. Hence, before they swallow all 4, I want to start with 1. The contents of these devices were not analyzed. Subsequently, so this is basically just a safety assessment. Can they just swallow 1 capsule? And, can they survive? Or are there any safety concerns? Subsequently, sets of 4 devices, with each device type within a set having a different enteric coating. So, like, the special coating on the capsule that will allow it to pretty much, it will do It will do the liquid sampling once it reaches a certain pH that it's designed to. Were ingested twice daily, 3 hours after lunch and 3 hours after dinner, on 2 consecutive days. All participants consumed their normal diets and kept a food log. All devices safely exited all participants and were successfully retrieved. No adverse events were reported. Participants collected contemporaneous saliva samples, 1 on each day before ingesting devices, 3 hours after dinner, and 2 days stool samples on or around the days when devices were recovered. We obtained sufficient sampling volume and 16S rRNA gene sequencing depth from 210 devices, 29 saliva samples, and 58 stool samples. And so this 16S rRNA gene sequencing, that's essentially our way of trying to see or actually characterize what types of microbes are there. Pretty much, we sequence a specific portion of their genome. This is 16S ribosomal RNA, and this is arbitrarily selected. All that to say is, like, pretty much virtually all bacteria have this, highly conserved or highly evolutionarily conserved, and so we just like look at this particular region on the genome of bacteria to determine, what species they are. This is basically our way of trying to classify them, actually characterize them. The pH profiles of the samples collected by the 4 devices reasonably matched previously published measurements of pH along the human intestines, with a general increase in pH from the proximal to distal small intestine, followed by a decrease in the ascending colon. The time between device ingestion and recovery ranged from 8 hours to 67 hours. Pretty huge range of time. It looks like some people pretty much expelled them pretty quickly. In line with previous reports of broadly distributed transit times, right? Oh, the Olive, welcome. Nice to see you. Outbreak. And yes, it should be on roughly, but I can't guarantee it, but I should be going for another hour and 15 minutes or so. But there's always the VOD on Twitch or YouTube if you're interested. I think I have it set up on YouTube. Yeah, that is the link where pretty much just about all VODs should be there. But yeah, I hope you're doing well. And yeah, I hope work is going okay and your new job is going okay. So yeah. Yeah, fair enough. I definitely enjoy the interaction with you as well. And so I'm glad that you're able to catch a little bit of it. But if you're also just interested in the content alone, then the VOD is there. But I am trying to make more content recently. So hopefully, more chances for interaction. But I know that you're a busy person. So given typical gastric emptying times and 3-hour post-meal interval before devices were swallowed, the devices probably entered the small intestine with the final contents of the preceding meal. Nonetheless, the contents of the subsequent meal were more strongly associated with device time. And here they get into pretty much, it looks like how they are determining the microbiome, characterizing it. The actual characterization is. Oh, I'm super sorry to hear that. My heart goes out to you. Yeah, I don't know what to say other than I'm really sorry to hear that you got scammed. And if you want to share, I'm curious to know. Yeah, I totally 1000% respect it. But at the end of the day, I hope you're doing okay. I hope. I'm glad that you're at least you have a place to go to with your parents. But if I remember correctly, it might be a little bit of a stressful situation. So I'm hoping that it's not too stressful. But yeah, at the end of the day, I hope overall that you're safe and keeping well. But I'm super sorry to hear that you got scammed. And I totally respect and understand that you want to discuss it. But I hope that you can get back on your feet as quickly as possible. And that I hope that, you know, have at least a decent place to stay for as long as you want until you can get back on here. But I know that, you know, parents are challenging and be tricky. We observed more intra-individual microbiota variability among intestinal samples than among stool or saliva samples, suggesting that the devices collect from a more heterogeneous habitat. Although device types 1 to 4 were designed to sample the intestines longitudinally, comparisons of microbiota composition among devices of the same type but swallowed at different times are potentially confounded by variability in meal contents, periprandial neurohormonal variations, intestinal motility, pH, and/or the intestinal microbiota itself. Okay, I understand. And yet, I think Canada, well, many regions are facing the same issue of rent too high. And yeah, that is a huge increase, which I'm sorry to hear. I'm glad, again, that you at least have your parents to go to. But yeah, that is like, that's pretty much like a 40-50% increase. That's crazy high. Which, yeah, I'm also sorry to hear that happened to you. That seemed pretty outrageous. Where was I? Ah, yes, here. Okay, well, at least there's that. And hopefully, you know, you're now able to save some money now that you're living with your parents. I hope so. But again, I totally understand. It might be a little bit more of a stressful situation for you. So we therefore assess technical and biological variability by having one participant ingest 4 devices of the same type simultaneously. This procedure was repeated twice for each device of types 1 to 4 over the course of 2 months. Devices of the same type ingested at the same time contained more similar microbial communities than devices of the same type ingested at different times. Interesting. So it seems like there is this aspect of like pretty much like time, or this temporal aspect of like, it seems like pretty much yeah, the more spaced out they are, the more diversity they observe, and that like if you pretty much like consume all 4 devices at the same time, then they're more similar, which I guess makes sense. Of like maybe it's literally just like trying to think of like small changes, or it's like, you know, if you swallow all 4 at the same time, then, you know, presumably, you know, they would kind of like pass through your GI tract in a fairly similar manner, although definitely not identical. They might be essentially sampling sort of roughly the same spots, as opposed to like if you stagger them, well then, like, you know, whatever, 1 hour at a time, then it's like, yeah, like this capsule is sampling here, or here in this region of the small intestine, and then this other capsule like might be close, but it might be like just a little bit too far away that you're getting something different. No longer in CNC though, now working for Amazon contract now. Gotcha. Well, I hope in addition to the increased salary, I hope that the working conditions are okay, and I hope you're being treated well. Dual planes. Okay. So then it seems like maybe it's a little bit easier, or, you know, deal with it better. Glad to hear. So the increased variance in microbiota composition due to this temporal variability is comparable to the variance due to spatial variability along the intestine, as assessed using sets of 4 devices of distinct types ingested at the same time. Moreover, intestinal samples, unlike saliva or stool samples, were often dominated by a single ASV with relative abundance of greater than 40%. Consequently, individual intestinal samples contain communities with lower alpha diversity relative to the intra-individual diversity, represented by all samples from a device of a certain type or by all samples from devices swallowed at the same time. Oh, gotcha. No problem. Either see you soon or take care and be well. And yeah, great to get an update from you. And yeah, I'm glad that overall, all things considered, you're okay. But still, super sorry to hear of what happened to you. Thus, much of the higher variability across intestinal samples relative to stool is probably due to the dynamic and heterogeneous nature of the microbiota along the intestinal tract. Right. So even though, let's just say their data collection, higher resolution, as in, they can essentially take samples, directly from the small intestine, or they can collect liquid directly from the small intestine. But even then, it's like, there's still challenges, or like, at least there's the advantage of at least they're seeing like, hey, there's so much variability of like, even if you do all 4 devices at the same time, or you stagger them and separated by time, you get different results. And maybe that's just a further testament to the diversity of the microbiome. Exercise science stream in the future. Are you talking about covering some of the science of exercise, or are you talking about a workout stream? Because I can totally do an exercise science stream, but a workout stream, unfortunately for the time being, like, those have been put on hold, sadly, because I've lost access to the place that I work out, that I used to work out, but I'm looking for a new place to hopefully do workout stream. But yeah, if you're specifically asking about doing a stream covering some science of exercise, totally do that. I even already did that for this stream, with this research about exercise and how it might have some benefits on the skin, in addition to all the other benefits exercise has. So yeah, bacteria remain viable within devices, but let's maybe back a bit. I'm not going to dissect this entire figure, because I'm not really in a position to, and even then, it's mostly just trying to, pretty much identifying the actual species microbiome that they're sampling. But yes, overview of the intended sampling locations, top of the 4 devices, device types in packaged form for ingestion, and as full collection bladders containing intestinal samples after retrieval from stool, bottom. A US dime is included for scale. Top right, the device contains a folded bladder capped with a one-way valve within a capsule with an enteric coating, which dissolves once the designated pH has been reached, enabling the bladder to unfold and draw in up to 400 microliters of luminal fluid. Okay, so they're talking about this panel here, panel A. I wish I had the ability to zoom in more. Don't. Okay, so they give an overall diagram of like their technology and the size. So it seems to be a little bit bigger than United States dime that they have here for scale. And they're highlighting which particular regions of the gastrointestinal tract that they are trying to target sampling. So yeah, you have like pretty much the first region, the small intestine, pretty much like almost the entirety throughout the small intestine. The duodenum, the jejunum, ileum, or like multiple sections. But yeah, it seems like they have it designed such that they're pretty much like taking regular samples, or at regular intervals throughout the small intestine. And then like, yeah, these are like the little bladders that are collecting the liquid from the small intestine. And then timeline for the collection of saliva, intestinal, and stool samples from 15 healthy individuals. Set 1 devices were not used for analyses. So this is B. Oh, okay. Not going to do C. Them looking at the abundance of certain bacteria. But D, the pH of the contents and devices designed to open at locations spanning the proximal to distal intestinal tract exhibited the expected increasing trend. Points represent individual devices. P values shown, yes, yes, yes. Okay. Oh, okay, so they're showing like the pH release. Or the pH. Yeah, the pH contents in the devices designed to open. Okay. It seems like they're trying to track, like, so. Yeah, trying to track, are the devices actually, doing what they're intended or designed to do? Because, like, some of the devices, so they're trying to, again, exploit the fact that there's this difference in pH as you go through your GI tract, or as you travel through your GI tract. And they've designed their devices, as highlighted earlier, that some devices, they'll start collecting once they reach this pH, or once they're exposed to this pH in the GI tract, and then other devices will start collecting once they've been exposed to this other pH. And it seems like, based off of my understanding, that they're trying to correlate like how the devices were designed, or designed to start collecting at which pH, and actually measuring the actual pH of the samples that they've collected, of like, hey, this device was designed to start collecting at pH 5. Well, does the sample that it actually collect, is it actually pH 5? That seems like what they're essentially graphing here, trying to tease out. And they pretty much graphed all the capsules that were swallowed. Yeah, it was like n is equal to 218. Okay. Got it. So yeah, the pH contents of the devices designed to open at locations spanning the proximal. Yeah. So it's like, what are the actual pH of the contents? And they're also this is also informative, because, like, hopefully not hopefully, it presumably can be used to confirm of, like, hey, we thought that this region of the small intestine was around pH like 6, and our device was designed to start collecting at pH 6. Well, is it actually pH 6 here? Well then, yes. Kind of like trying to actually confirm basically what previous research has shown about how the pH changes throughout your GI tract. The That was here. Yeah, bacteria remain viable within devices. To determine whether the intestinal microorganisms collected by the capsule devices were viable, participant 1 ingested a device designed to collect from the proximal region of the intestines. An aliquot, that's just fancy terminology for, a small amount of liquid of the sample, was retrieved under anaerobic conditions ex vivo and placed on an agarose pad with nutrients. So they're essentially trying to, presumably, we are collecting samples of the microbiome. And I'm sure there's a bunch of, like, whatever non-living stuff in there, but there should be, presumably, some living stuff in there. And your GI tract, or rather, let's say your small intestine, or rather, whatever, your intestinal tract, or generally speaking, your GI tract, is an anaerobic environment, as in, not oxygen rich or absent of oxygen. And so it's like, yeah, this person ingested a capsule, and then, it was retrieved, okay? And then, before opening the capsule and extracting the sample, they brought it into anaerobic conditions, okay? Because, they don't necessarily want to, they don't want to essentially contaminate it with oxygen. Since it was collected, sample was collected in an environment where there's essentially like very limited or essentially like no oxygen, anaerobic conditions. And then, yeah, they placed it basically on something that should hopefully allow it to grow, survive and grow. Yeah, the pad, that's why they're including nutrients of like, basically, can we cultivate and grow what was inside this particular person that swallowed the capsule. The pad was sealed to prevent oxygen from diffusing to the cells and subjected to time-lapse imaging. Over 4 hours, 20 to 50% of cells resumed growth. A similar regrowth fraction was observed in anaerobic resuspensions of fresh stool, indicating that the devices preserve live bacteria to the same degree as seen with fresh stool. The growing cells recovered from the device collectively displayed a wide range of morphologies, suggesting that regrowth is not heavily biased towards a few taxa. Supporting this conclusion, we used plating and flow cytometry to obtain a library of 456 isolates from several intestinal samples from participant 1 and 31 isolates from stool samples from participant 1. So really focusing on, one particular participant. Comprising at least 51 unique species across 4 phyla. In our time-lapsing imaging, we also noted occasional human cells that were probably epithelial cells on the basis of their morphology, in line with the small fraction of metagenomic reads from these samples that mapped to the genome. Taking these findings together, the devices enable culturomics experiments and may provide the opportunity to study host cells present in human. So yeah, they're not just like, only collecting dead material, but it seems like collecting live stuff that can actually be grown outside of the conditions of the intestines. To evaluate functional differences, here they're going to get into the nitty-gritty of like, characterizing the microbiome. And not only just like all the stuff that's there, but all of like the metabolic products, I would assume. You give me a second. Increased prophage. Yeah, this is more characterization of the microbiome. Spatial variation. Oh yeah, more characteristic. They're doing a lot of in-depth characterization. Understandably. Microbial links, amino acid, specific bile acid conjugation. Yeah, makes sense why this paper is so long. So, wrapping up. Or rather, what are their overall summary of their findings? Even though there is a lot of results here. They did a lot of work, which makes sense. Should have highlighted this earlier. Of like, a lot of researchers were involved in this study. And their affiliations, you have a lot of Stanford, University of California, more Stanford, University of California, Infectious Disease Section, Veterans Affairs, Palo Alto, Max Planck Institute Biochemistry in Germany. So yeah, basically, a lot of Stanford researchers, sense, but still, pretty much a multidisciplinary study. That's a lot of researchers from various disciplines coming together, because this is pretty ambitious. This is in addition to this being sort of like, a biology question, or biology research, it's also well, clearly there's like an engineering aspect as well, because like there's an actual technological aspect to it, of like, this is like, a a camera pill, or like a pill. I don't know if it has camera capabilities, actually. I think it seems like it's just designed to collect liquid samples. But regardless, this is still, there's some sort of engineering aspect here. Well, at least my experience, and biologists aren't trained to design capsules that can collect liquid samples. Like, yeah, identify bacterial species and such, and microbial communities. The actual design of the capsule, that's an engineering aspect. So yeah, it makes total sense that a lot of researchers were involved, because like, yeah, this is pretty ambitious. And also, again, even though, as mentioned many times, I don't pay much attention to the prestige of a journal, or like, yeah, something being published in Nature only means so much to me. But at least in reality, like, the fact that this is published in Nature also says something in terms of like, this is a high impact, ambitious research, generally speaking. So thus far, studies of the human gut microbiome and metabolites have relied mainly on stool. In this study, enabled by the development and implementation of an ingestible sampling device, we demonstrated that analysis of stool provides neither a complete nor an accurate representation of the longitudinal and temporal variability of the microbiota composition, virus activity, host proteome and bile acid contents within the intestines. The trends in microbially conjugated bile acids were strong and novel. And although it remains unclear why bile acids exhibit distinct abundance profiles along the intestinal tract, our data provide the opportunity to identify the bacterial species and genes responsible for these transformations and profiles. The wide variability among intestinal samples, both within and across individuals, highlights the dynamic environment of the small intestine and the need for increased sampling, both longer term and in larger cohorts, to determine baseline variation expected in healthy individuals before studies of disease states can be robustly evaluated for differences in spatio-temporal variability or overall community composition. With that understanding, we envision interrogating how diet and disease differentially influence intestinal microbiota, metabolome, virome, and proteome. Indeed, measurements from the proximal intestinal microbial ecosystem will be critical for future clinical studies of spatially restricted human intestinal diseases and therapeutic interventions directed at these disorders. In a companion study, we interrogate spatial and temporal differences in intestinal metabolomes in further detail, including changes into dietary and lipid compounds. We report the detection in humans of sulfonolipids, which were associated with several microbial taxa, as well as an association of FAH-FA lipids with Platia species. Taken together, these studies demonstrate the feasibility and utility of a safe and non-invasive method for collection, characterization, and quantification of the intestinal microbiota, metabolome, host proteins, and bile acids along the human intestinal tract during normal digestion. This new capability, when deployed at scale, should improve understanding of the dynamic and intertwined nature of human metabolic pathways with our resident gut microorganisms and their potential involvement in normal physiology and disease. So yeah, they're highlighting here a lot of potential promise. If in fact, I'm sure there's still further improvements to make with this technology. But it seems like, based off of, what they've covered here, that this works, it's effective, and that, might be closer to widespread application than we think. In Bali, renting a place with a mini pool for only 350. Wow. Uh, that is well, 350 United States dollars. Or regardless, seems like it's much more livable, which I'm happy to hear. Although, just like any country, including Canada, no perfect place to live. But yeah, there is definitely an issue of housing, affordable housing in Canada, and I think just pretty much in developed countries, largely speaking, or at least in North America. That's mostly what I see in my newsfeed of the United States and Canada, and affordable housing issues. But yes, this is super cool. I'm curious to see what other data that they have. Growing cells recovered from devices collectively displayed a wide range of morphologies. Okay, so it looks like they were actually able. Device imaging, growing cells displayed a wide range more, highlighted by white arrows. Okay, so yeah, so they did a lot of characterization. I couldn't even begin to dissect all of the characterization that they have done. I'm literally trying to dissect what dozens of researchers have generated. I'm not that ambitious. But I'm curious. The inclusion criteria: age between 18 and 70. American Society. Oh, interesting. One for women of childbearing age. Let's see in English. They don't really mention how they recruited. Maybe I'm missing it. Studies were approved by, this review board. Informed consent was obtained from each participant, but how do they get the participants? Okay, so yeah, on this capsule sampling device seems like it's made by a private company. I'm curious if there's a conflict of interest. There probably is. Yes, that makes sense. So DS is an employee of In Vivo Bio and owns stock in the company. DS is an inventor on pending patent application covering the sampling device described in the manuscript, which is owned by In Vivo Bio. All other authors declared. So yes, is this person here, Gary Shalom. Which yeah, makes sense. They're the primary author. So yeah, that is good to know. Not that this does not invalidate the research at all. This is undoubtedly still high quality, pretty powerful research. It's just something to take note of. That there's ever so slight incentive to make it look good. I think there are enough other researchers that have no competing interests. Everything here is still valid. Still trying to see how they recruited. But yeah, interestingly enough, they even mention recruit at all. No, don't. Just say enrolled. which is interesting. Regardless, yeah, super cool. I think pretty coincidental. Uh, I mentioned it just yesterday of like, hey, maybe so there's probably in development some sort of capsule device that has the ability to sample. But I was a little bit off because I was hoping for a device that has the ability to like take a biopsy sample, not necessarily a microbiome sample, but still, this is like sort of a step in that direction. But basically, this is just like collecting liquid, not yet able to like take a tissue sample. So it's not really, at least so far, doesn't seem like it's in the direction or category of something that's diagnostic. Unless we can get to a place of like through characterization of the microbiome, we can diagnose some sort of disease or condition. And I'm pretty sure we're not there just yet. But like, yeah, I'm sure, again, probably at some point, there will be some sort of capsule device that has the ability to like take also a tissue sample. 1 second. And yeah, a lot of the microbiome research, pretty cool. One of the, in my mind, the coolest sort of things that I probably need to update my information because a little bit of an older paper. But yeah, there's a lot of talk about the microbiome, understandably, and there's a lot of emerging research about the microbiome, as we just covered. And there's also research of like, hey, how can we do better to characterize the microbiome? And as I just mentioned yesterday, microbiome is implicated in my own disease, Crohn's disease, where there appears to be some sort of role for the gut microbiome in the inflammatory process or the disease process. But then there's also research like this that's a little bit old, not super old, but like 7-8 years, published in 2015. But there's also this other aspect of like, this is also just a testament to how complicated the environment of our GI tract is. Of like, yeah, we know that there are bacteria. Well, there's pretty much a whole host of microorganisms. We have bacteria, we have fungi, and we have also viruses, where there's also a virome. And interestingly enough, okay, and this is where it gets like super tricky. Although I haven't, I'm sure there's more research that has been published since I read this, but at least back then, this is sort of like calling into question, or like maybe putting a question mark of like, hey, when microbiome research was applied to Crohn's disease patients, we definitely saw differences in that, comparing the gut microbiome of a Crohn's disease patient to a typical healthy person. There's clear difference in their bacterial communities. Generally speaking, less diversity in the Crohn's disease patient. And it was just sort of thought, or like the question was, well, okay, is this a cause of the disease, or is it the result of the inflammation? Pretty much, the unique environment of a Crohn's disease patient, that it's is an inflammatory condition. Is that just altering the gut microbiome of the person? Cause or effect, basically. But then there's this aspect of like also the virome. There's disease-specific alterations in the virome in Crohn's disease patients, or inflammatory bowel disease patients at large. And it seems like, again, based off of this research, that the virome, well, these are viruses that infect bacteria. Bacteria can essentially get sick, and are, well, viruses infect bacteria. There are viruses that infect other viruses. Like viruses are just like super interesting, and they're just like a wild world that goes on there. But then, yeah, when this research came out, it sort of calls into question of like, well, maybe what we're observing at the microbiome level is the results of what's happening at the virome level. As in, hey, maybe something is happening with the virome, okay, and that these viruses that infect bacteria, okay, since those are changing, okay, that might have an effect on the bacterial community. As in, like, if there's, let's say, less viruses there that infect bacteria and maybe, you know, wipe away certain bacterial communities, well, maybe that's what we're observing. As in, it's not actually, you know, an actual change in the gut microbiome that's driven by the inflammation, or that is playing a role in the disease process. But maybe it's the fact that, oh, the virome is different, and the virome affects microbiome. But that's still like an open, or at least when I read this, still an open question. But they were like posing that. Where, yeah, sort of decreases in bacterial diversity and richness in naivety do not explain virome changes. As in, the changes that they're seeing, they don't seem to be coming from the changes of the microbiome. And that it seems like it's disease specific. But I haven't followed up on this line of research recently. I probably should, because it's super cool. And yeah, I have no doubt that probably in 8 years since it's published, more research has come out. So those are the two studies that I wanted to cover. I have some smaller articles that I want to go over, although I don't think I have time to cover all of them, which, you know, no surprise, usual. I never get to all the content that I want to cover, but at least I covered the main topics that I wanted to. But I did want to go over this article, switching topics, because this was sent to me by a community member. And was published fairly recently, in the past couple weeks, or exactly 2 weeks, about how pollution cuts have diminished ship track clouds, adding to global warming. For changing the clouds, an unintended test of geoengineering is fueling record ocean warmth. The Atlantic Ocean is running a fever. Waters off Florida have become a hot tub, bleaching the third largest barrier reef in the world. Off the coast of Ireland, extreme heat was implicated in the mass death of seabirds. For years, the North Atlantic was warming more slowly than other parts of the world, but now it has caught up, and then some. Last month, the sea surface there surged to a record 25 degrees Celsius, nearly 1 degree Celsius warmer than the previous high, set in 2020. And temperatures haven't even peaked yet. This year it's been crazy, says Tianol Yuan, an atmospheric physicist at NASA's Goddard Space Flight Center. The obvious and primary driver of this trend is society's emissions of greenhouse gases, which trap heat that the oceans steadily absorb. Another influence has been recent weather, especially stalled high-pressure systems that suppress cloud formation and allow the oceans to bake in the sun. But researchers are now waking up to another factor, one that could be filed under the category of unintended consequences: disappearing clouds known as ship tracks. Regulations imposed in 2020 by the United Nations International Maritime Organization have cut ships' sulfur pollution by more than 80% and improved air quality worldwide. The reduction has also lessened the effect of sulfate particles in seeding and brightening the distinctive low-lying reflective clouds that follow in the wake of ships and help cool the planet. The 2020 IMO rule is a big natural experiment, says Duncan Watson Paris, an atmospheric physicist at the Scripps Institution of Oceanography. We're changing the clouds. By dramatically reducing the number of ship tracks, the planet has warmed up faster. Several new studies have found that trend is magnified in the Atlantic, where maritime traffic is particularly dense. In the shipping corridors, the increased light represents a 50% boost to the warming effect of human carbon emissions. It's as if the world suddenly lost the cooling effect from a fairly large volcanic eruption each year, says Michael Diamond, an atmospheric scientist at Florida State University. The natural experiment created by the IMO rules is providing a rare opportunity for climate scientists to study a geoengineering scheme in action, although it is one that is working in the wrong direction. Indeed, one such strategy to slow global warming, called marine cloud brightening, would see ships inject salt particles back into the air, make clouds more reflective. In Diamond's view, the dramatic decline in ship tracks is clear evidence that humanity could cool off the planet significantly by brightening the clouds. It suggests pretty strongly that if you wanted to do it on purpose, you could, he says. The influence of pollution on clouds remains one of the largest sources of uncertainty in how quickly the world will warm up, says Franziska Glassmeyer, an atmospheric scientist at the Delft University of Technology. Progress in understanding these complex interactions has been slow. Clouds are also variable, Glassmeyer says. Some of the basic science is fairly well understood. Sulfate or salt particles seed clouds by creating nuclei for vapor to condense into droplets. The seeds also brighten existing clouds by creating smaller, more numerous droplets. The changes don't stop there, says Robert Wood, an atmospheric scientist at the University of Washington. He notes that smaller droplets are less likely to merge with others, potentially suppressing rainfall. That would increase the size of clouds and add to their brightening effect. But modeling also suggests that bigger clouds are more likely to mix with dry air, which would reduce their reflectivity. Even before the IMO regulations, ship tracks have been a target for researchers to test these ideas. Given their striking appearance, these linear clouds were a natural candidate for artificial intelligence-based image recognition, Yuan says. Using such techniques, and 2 decades of calibrated imagery from NASA's Ailing, Terra, and Aqua satellites, Yuan and co-authors discovered 10 times more ship tracks than previously identified using manual techniques. In their study, published last year in Science Advances, they also found these tracks decreased by more than 50% in the main shipping corridors after the IMO regulations. In more recent work, they take this analysis a step further, calculating the amount of cooling associated with the track's brightening effect and the way the pollution extended the lifetime of the clouds. IMO rules have warmed the planet by 0.1 watts per square meter, double the warming caused by changes to clouds by airplane, they conclude in a paper under review. The impact is magnified in regions of heavy shipping, like the North Atlantic, where the disappearing clouds are a shock to the system, Yuan says. The increase in light, which was worsened by a lack of reflective Saharan dust over the ocean this year, can account for most of the warming observed in the Atlantic this summer, he says. Instead of focusing on visible tracks, Watson Paris and his colleagues started it with ship location data, combining those coordinates with weather records to project where the ship's pollution traveled. They compared clouds at these locations with nearby clouds free of any ship pollution. In Nature last year, they reported that these individual ship tracks not only enhanced low-lying marine clouds as usual, but also markedly increased the volume of puffy cumulus clouds higher in the atmosphere, previously thought to be immune to the influence of ship pollution. They concluded that air pollution could be causing clouds to cool the climate at roughly double the previously projected strength. However, when the team then looked at the effect of the IMO rules on these visible tracks, they received a shock. The decline in pollution didn't make the cumulus clouds any less puffy, they report in a new preprint in Atmospheric Chemistry and Physics. It suggests these clouds have a saturation point, after which added pollution does little to increase their depth, Watson Paris says. We removed 80% of the aerosols, but that's still not taking us close to the pre-industrial state. A third way to explore the impact of ship pollution on clouds is not to study them in aggregate, but rather to zoom in on ocean stretches where winds flow in parallel with shipping lanes, keeping the pollution tightly corralled. Such a stretch exists in the southeast Atlantic, off the coast of Angola. Observing this region with the Terra satellite, Diamond found that with lower pollution, the cloud droplet sizes had grown to the largest size by far in the past 2 decades. Extrapolating from there, Diamond estimates in a paper last week in ACP that the IMO rules have caused warming globally at levels like those seen by Yuan. Later this year, Diamond, Yuan, and others will begin to compare the techniques for studying the interaction of pollution and clouds under the auspices of the National Oceanic and Atmospheric Administration's Small Geoengineering Research Program. After a few more years, which says we're really going to have something to say about these cloud adjustments. Clarification. The word unforeseen in the story's headline has been changed to unattended because researchers had previously predicted that lower ship pollution could lead to diminished clouds and higher temperatures. Interesting. Well, like, still a lot of unanswered questions, but basically a testament to the importance of research, of understanding this phenomenon, and then, like, what to do about it, and, like, you know, how do we move forward? Or, like, what's the appropriate response once we've characterized fully this phenomenon? And then probably the last article, is related to the microbiome research that I covered. And one of the reasons why, you know, there's fairly intensive research efforts to hopefully ensure that we can, diligently or robustly characterize the human microbiome. Because there's this thing called the psychobiome. As in, mounting evidence that gut bacteria influence the nervous system inspires efforts to mine the microbiome for brain drugs. And this was published a few years ago, so it's not like breaking news still in the past 3.5 years. But again, just a testament to still how much more there is to learn about the microbiome. Katya Gavrish is searching for new brain drugs in a seemingly unlikely place, human stool samples. And again, as highlighted in the last article, some clear drawbacks in relying on stool samples to characterize or, extract information about the microbiome. An earnest and focused microbiologist who trained in Russia and loves classical music, he's standing in front of a large anaerobic chamber in a lab at holobiome, a small startup company here. She reaches into the glass-fronted chamber through Michelin Man-like sleeves to begin to dilute the sample inside. That's the first step toward isolating and culturing bacteria that Gavrish and her holobiome colleagues hope will produce new treatments for depression and other disorders of the brain and nervous system. The 8-person company plans to capitalize on growing evidence from epidemiological and animal studies that link gut bacteria to conditions as diverse as autism, anxiety, and Alzheimer's disease. Since its founding a mere 5 years ago, holobiome has created one of the world's largest collections of human gut microbes. The company's CEO, Phil Strandwitz, cannot yet say exactly what form the new treatments will take. But the targeted ailments include depression and insomnia, as well as constipation, and visceral pain like that typical of irritable bowel syndrome, conditions that may have neurological as well as intestinal components. Strandwitz, a mild-mannered Midwesterner with a PhD in microbiology, isn't prone to visionary statements, but neither is he short on ambition. He predicts the first human trial will start within 1 year. Presumably, this is happening now or has taken place, because it was published 3 years ago. So maybe I'll have to follow up. The allure is simple. Drug development for neuropsychiatric disorders has lagged for decades, and many existing drugs don't work for all patients and cause unwanted side effects. A growing number of researchers see a promising alternative in microbe-based treatments, or psychobiotics, a term coined by neuropharmacologist John Cryan and psychiatrist Ted Dinan, both at University College Cork. This is a really young and really exciting field with a huge amount of potential, says Natalia Palacios, an epidemiologist at the University of Massachusetts, who is looking into connections between gut microbes and Parkinson's disease. Some researchers prefer a less hurried approach focused on understanding the underlying biology, but holobiome and a few other companies are eager to cash in on the burgeoning multi-billion-dollar market that has already sprung up for other microbial therapies, which aim to treat conditions including intestinal disorders, allergies, and obesity, Those companies are pushing ahead despite many unresolved questions about how psychobiotic therapies might actually work and the potential dangers of moving too fast. There's a gold rush mentality, says Rob Knight, microbiologist at the University of California, San Diego. Over the past 20 years, the recognition that the microbes living inside us outnumber our body's own cells has turned our view of ourselves inside out. The gut microbiome, as it's known, weighs about 2 kilograms, more than the 1.4 kilogram human brain, and may have just as much influence over our bodies. Thousands of species of microbes, not only bacteria, but also viruses, fungi, and archaea, reside in the gut, right? As mentioned earlier, and going back to sort of that virome research I brought up. Yeah. There's the gut microbiome, which gets a lot of attention. Oh, no problem, Oily Olive. And yeah, great to see you. Great to again get an update from you. Yeah, hope you're keeping well and hope to receive another update soon. But yeah, the VODs on the YouTube or on the Twitch. But yeah, so yeah, the gut microbiome gets a lot of attention, but there's a whole bunch of other stuff going on in our GI tract that we're still trying to out. There's the virome, there's fungi, there's archaea, pretty much, you know, a whole host of various microorganisms. And with as many as 20 million genes among them, those microbes pack a genomic punch that our measly 20,000 genes can't match. Gut bacteria can make and use nutrients and other molecules in ways the human body can't, tantalizing source of new therapies. And like, yeah, essentially what they're saying is, you know, we have our own genome, but essentially our genome pales in comparison to, like, you know, the entire kind of like, you know, microbiome genome that's in our GI tract. Of like, there's just like way more than 20,000 genes that are, you know, making things, breaking down things, and, you know, just all basically not only just microbial diversity, but metabolic diversity. The brain is the newest frontier, but it's one with an old connection to the gut. The ancient Greeks, for example, believed mental disorders arose when the digestive tract produced too much black bile. And long before microbes were discovered, some philosophers and physicians argued that the brain and gut were partners in shaping human behavior. What probably happens is that our brain and our gut are in constant communication, says Brian, who over the past decade has helped drive efforts to decode those communications. Bacterial residents of the intestine may influence. So they're providing some mechanisms or ways in which, you know, maybe what goes on in our gut and affect other things in our body. So substances secreted by microbes into the gut may infiltrate blood vessels for a direct ride to the brain. Microbes prompt neuropod cells in the gut lining to stimulate the vagus nerve, which connects directly to the brain. More indirectly, microbes activate enteroendocrine cells in the gut lining, which send hormones throughout the body. And even more indirectly, gut microbes influence immune cells and inflammation, which can affect the brain, right? Epidemiological researchers have turned up intriguing connections between the gut and brain disorders. For example, many people with irritable bowel syndrome are also depressed. People on the autism spectrum tend to have digestive problems. People with Parkinson's are prone to constipation. Researchers have also noticed an increase in depression in people taking antibiotics, not antiviral or antifungal medications that leave gut bacteria unharmed. Last year, Jeroen Reyes, a microbiologist at the Catholic University of Leuven, and colleagues analyzed the health records of two groups, one Belgian, one Dutch, of more than 1,000 people participating in surveys of their types of gut bacteria. People with depression had deficits of the same two bacterial species, the authors reported in April 2019 in Nature Microbiology. Researchers see ways in which gut microbes could influence the brain. Some may secrete messenger molecules that travel through the blood to the brain. Other bacteria may stimulate the vagus nerve, which runs from the base of the brain to the organs and the abdomen. Bacterial molecules might relay signals to the vagus through recently discovered neuropod cells that sit in the lining of the gut, sensing its biochemical milieu, including microbial compounds. Each cell has a long foot that extends outward to form a synapse-like connection with nearby nerve cells, including those of the vagus. Indirect links may all, well, they're just describing the figure, but regardless. Increasingly, researchers see inflammation as a key factor in disorders such as depression and autism. And we just covered a little bit of inflammation when it comes to, exercise or the benefits of exercise, and maybe, how anti-inflammatory effects of exercise might, result in improvements in our skin, or, this skin rejuvenation property. Gut bacteria are key to proper immune system development and maintenance, and studies show that having the wrong mix of microbes can derail that process and promote inflammation. And microbial products may influence what are known as enteroendocrine cells, which reside in the lining of the gut and release hormones and other peptides. Some of those cells help regulate digestion and control insulin production, but they also release the neurotransmitter serotonin, which escapes the gut and travels throughout the body. If I remember correctly, the largest concentration of serotonin is contained in your gut or in your GI tract. Although the mechanisms remain elusive, animal studies by Cryon and others have bolstered the idea that gut microbes can influence the brain. Rats and mice given fecal transplants from people with Parkinson's, schizophrenia, autism, or depression often develop the rodent equivalents of these problems. Conversely, giving those animals fecal transplants from healthy people sometimes relieve their symptoms, but I would say a little bit more complicated than that, or it's not like a one-to-one. Definitely doesn't seem curative. The presence or absence of certain microbes in young mice affects how the mice respond to stress as adults, and other mice studies have pointed to a role for microbes in the development of the nervous system. And again, these are mouse studies. I already highlighted earlier some of the obvious shortcomings of relying on mouse studies. There's reasons why, again, they're trying to develop the technology, sample the human gut microbiome. I was like, yeah, we could sample mouse microbiome, but we are not mice. At their lab, Cryon, Dinnan, and their colleague, Gerard Clark, think the amino acid tryptophan, which some gut bacteria produce, could be a causal link. Microbes, or the body's own cells, can convert tryptophan into serotonin, a neurotransmitter implicated in depression and other psychiatric disorders. Cells also turn tryptophan into a substance called kynurenine, which reacts further to form products that can be toxic to neurons. Changes in the microbiome might tip the production of those various substances in a way that impairs mental health, Cryon says. Research has shown, for example, that people with depression convert tryptophan into kynurenine more readily than into serotonin. Cryon's group has amassed scores of papers and reviews that have helped solidify the case for microbial effects on several psychological and neurological disorders, but teasing effective fixes out of those links will be difficult, Clark says. It is one thing to know that a particular aspect of host physiology is influenced by our gut microbes, and quite another to bend this influence to our will. Clark's group collaborates and consults with many companies and has tested some potential psychobiotics for stress management in healthy volunteers, but he sees a long road to treatments. It will be important to understand better and more precisely the mechanisms at play. But looks like Holobiome isn't as patient. Strandwitz founded the company in 2015 while still a graduate student in Kim Lewis's microbiology lab at Northeastern University. He very politely told me that he would join the lab only if I helped him start a company once he graduated, recalls Lewis, who is famous for discovering and working to commercialize new antibiotics from soil microbes. Lewis agreed, but he figured it would be 10 years or more before Strandwitz would have his own company. Lewis was wrong. It only took 4 years. At Northeastern, Strandwitz learned that what he calls the art of cultivation from Gavrish, who was working with Lewis on isolating soil microbes. At the time, only about 25% of gut bacteria could be grown in the lab, and this is kind of a known thing in microbiology. Pretty much the vast majority of microbes in the environment, or like in the world at large. We basically cannot grow them in the lab. Pretty much like greater than 99%, or like, less than 1% of the microbes, microorganisms or bacteria in our environment, and we actually grow under lab conditions, no matter like what we do. We do as best we can very often to like simulate their native conditions, and we just like fail miserably. Don't really know why. Gavrish, who specializes in isolating and describing new microbial species, taught Strandwitz to manipulate nutrients and use antibiotics to give low-growing, picky bacteria a chance to survive in culture, instead of being outcompeted by more aggressive species. He began to track down growth factors to keep recalcitrant species going. Now, Strandwitz says, we have in culture about 70% of the known human gut microbes. If true, it's a figure few other labs can match. One growth factor Strandwitz identified turned out to be the key to launching his entrepreneurial dreams. He and colleagues isolated a bacterium that couldn't survive on typical culture media and required an amino acid called gamma aminobutyric acid, GABA, to thrive. This is pretty common, as they say, neurotransmitter, and even pretty often taken as a dietary supplement. GABA is a neurotransmitter that inhibits neural activity in the brain, and its misregulation has been linked to depression and other mental health problems. The researchers reasoned that if this gut microbe had to have GABA, some other microbe must be making it. Such GABA producers might be a psychobiotic goldmine. Strandwitz and colleagues began to add gut microbes one at a time to petri dishes containing the GABA eater. If the GABA eater thrived, the scientists would know they'd found a GABA producer. They discovered such producers among 3 groups of bacteria, including Bacteroides. Quickly filed a patent for packaging those bacteria or their products to treat people with depression or other mental disorders. Before publishing those findings, the group teamed up with researchers at Weill Cornell Medicine who were doing a brain scan study of 23 people diagnosed with depression. They found that people with fewer bacteria had a stronger pattern of hyperactivity in the prefrontal cortex, which some researchers have associated with severe depression. The collaboration reported its findings on the 10th of December 2018 in Nature Microbiology, along with the discovery of GABA-producing bacteria. Holobiome further discovered that the bacteria produce GABA in the rat digestive tract, and which may increase GABA levels in the brain. And it found that GABA producers reduced learned helplessness, a symptom of depression in those animals. One of Strandwitz's co-authors, microbial ecologist Jack Gilbert at UC San Diego, is also testing the therapeutic potential of GABA-producing bacteria in rats. His group and Holobiome have both observed that treated rats are more likely to stay longer on an uncomfortably warm surface, a test of visceral pain tolerance, perhaps because elevated GABA calms them. The findings are unpublished. They've persuaded Gilbert to investigate whether those bacteria can also reduce anxiety in rats. It's clear they do have a neuromodulatory effect, he says. GABA is too big to reach the brain by slipping across the blood-brain barrier, a cellular defense wall that limits the size and types of molecules that can get into the brain from blood vessels. Although I've seen, or rather I've read, sort of conflicting information about this. Or I have come across information that points to that maybe some GABA can get through the blood-brain barrier. Or just like, the amount that can get through the blood-brain barrier is limited. But I probably need to follow up with that. I don't want to make an inaccurate claim. But I seem to have in my brain reading something that calls this into question. Of like, there might be some possibility that GABA can reach the blood-brain barrier because it's not that big. It's a small molecule, like a few hundred Daltons. It's less than that. Not even a few hundred. Pretty much exactly 100. Yeah. Not sure. Yeah, I'm not so certain about this claim. But regardless. But instead, the molecule may act through the vagus nerve or the enteroendocrine cells. Some researchers might question why bacteria would be any more beneficial than GABA boosting drugs, but Strandswitz says the bacteria may do more than simply boost GABA. He notes that they produce molecules that may have other effects on the brain and body, thereby addressing other symptoms of depression. He and Gilbert are unfazed by those uncertainties. We can show an influence without any side effects. I don't see any reason for not going forward with clinical trials, Gilbert says. At holobiome, Stranwitz and colleagues have identified and ranked 30 promising GABA-producing bacteria, including the ones Gilbert is testing. Now the company is enlisting an outside manufacturer to figure out which GABA-producing bacteria are best suited to produce in large enough quantities to test in people. The researchers hope to complete regulatory and ethical reviews in time to start human trials by early 2021. We've been able to progress at this rate because we know our microbiology, Strandwitz says. The initial target conditions are insomnia and irritable bowel syndrome with constipation. Ultimately, holobiome does not know whether its best products will be a single bacterial species, a group of species, or a compound made by bacteria. For now, live bugs work the best, Strandwitz says. He suggests a consortium of bacteria that includes a wider range of species than typical probiotics will be more versatile and able to treat multiple aspects of, say, depression. Holobiome is already looking beyond GABA producers. Thousands of newly isolated microbes wait in frozen vials at the company's headquarters for their psychobiotic potential to be explored. Whenever we see someone publishes a new paper on the microbiome, we can check if we have those bacteria and replicate the experiments, says Holobiome's Steven Skolnick, who recently joined the company. A key tool for those experiments is a gut simulator, a series of flasks connected by tubing with several portals for adding microbes and for monitoring what's happening inside. By allowing a mock microbiome to develop from different combinations of bacteria, sometimes with mammalian cells in the mix, researchers can investigate newly isolated microbes and their products. If the scientists see promise, they can quickly pivot to thinking about additional products to develop. Skolnick took the lead on obtaining a patent for Holobiome's use of cuine, a vitamin-like molecule only produced by certain gut microbes, to improve mental well-being. The body uses cuine to build neurotransmitters such as dopamine, serotonin, and melatonin. Whether adding cuine producers or the molecule itself to the gut might help people with mental illness isn't clear. Ms. Strandwitz says he's excited about the idea. It's been amazing to witness the tremendous growth in the microbiome gut-brain field, says UC Los Angeles biologist Elaine Thau. Like Strandwitz, he is an enthusiast, having helped start 2 companies to develop microbial therapies for several disorders, including epilepsy and autism. Other researchers fear entrepreneurship is outracing science. Knight says venture capitalists are funding startups developing almost any microbiome-based therapies. Some concepts are very promising and are supported by a lot of evidence, he says, but others aren't, and they're still getting money. Knight says investors see an opportunity in eager patience. Reyes says he gets almost daily emails from depressed people. Help, right? One of the key issues when it comes to, private companies, or let's say biotech companies, trying to develop therapies or treatments for patients, where it's like, very often there's a lot of enthusiasm and a lot of like early investment, but like that early investment is like, based off of, maybe low quality or like, sketchy research. Theranos, or situation with Theranos happened for a reason. Not that there was any research there to back up any of the claims, but very often, once you build just a little bit of enthusiasm, there can be like this snowball effect of like, hey, well, if other people are investing, well then, that will just sort of encourage other people to invest as well, because they don't want to miss out on, the potential gold mine. And, again, with my limited experience in sort of like the biotech startup world, very often the people that are investing in these things are like, there is a disconnect between like the people. There's sometimes a disconnect between the people investing in these things and the people actually doing the science and research and development, where uh, where sometimes the people doing the investing or providing the funding, don't they're not scientifically informed, and so they're relying, or they're very often relying on the actual scientists to inform them, hey, this is what we're doing, and this is the our sales pitch. Microbial therapies won't necessarily meet the same standards of efficacy as regular drugs. To be marketed as a pharmaceutical, a treatment has to pass muster with the U.S. Food and Drug Administration, or its equivalent in other countries, through clinical trials that prove its effectiveness against specific diseases. Most microbiome treatments so far are marketed as probiotics, for which regulatory thresholds are lower, at least in the United States, as are limits on the health claims that a manufacturer can make. Holobiome is developing both types of products. The field still faces considerable scientific questions. Besides the correlative nature of much of the research and the usual questions of whether animal studies will translate to humans, there's also the sheer complexity of the human microbiome, says Beatrice Burnaby, systems reproductive biologist at the University of Illinois, Chicago. I don't think that it will be one thing fits all. We will need to look for specific strains and dosages for different people. And she adds, new theories and models are needed to predict how those strains will affect the individual's particular microbiome community. Right. So again, highlighting sort of the same issue or shortcomings with a lot of the microbiome research. And again, just further reason as to why they're trying to develop technology, the capsule technology that can, sample the human microbiome at the actual location, collect liquid samples. Because again, some of the research, we're extrapolating some of the evidence found in mice or other animals and trying to apply it to humans. And we might be developing therapies based off of data generated in mice or other animal models. Despite the obstacles, Gavrish remains confident that some strains she's growing in the anaerobic chamber will lead to treatments. After all, she says the connection between gut microbes and the human brain has deep evolutionary roots. I truly believe you can harness the power of 1,000,000 years of signaling by gut bacteria to help people. This article has been edited to clarify that cueing is not a building block for neurotransmitters, and the GABA producers, not eaters, were found to reduce learned helplessness. Okay, good to know. So yeah, pretty cool in terms of an ambitious endeavor. But as mentioned, this is a few years old, and it seems like their ambition or their goal was to start doing things, human trials within 1 year. Does Holobiome have a website? Is it still around? News. So looks like their last news update was over a year ago. Okay, well, not a lot going. I mean, I think we literally just read this article. So looks like they have a pretty sizable team. Oh, and George Church, well, scientific advisor. George Church has his hands in this. And they're big name biology or molecular biology. Yeah, curious to follow up to see if they've published any research. Doesn't look like it. Is there? Never mind. Okay, well, potentially no surprise that their goal was human trials within 1 year, and that is actually happening. which is pretty standard in the biotech world. You know, bold claims, and ambitious timelines, and timelines that are never upheld. But with that, I think I'm gonna end the stream here, since yeah, covering papers took longer than expected, but that is not a complaint on my part. Again, always enjoy covering a paper in depthly, or papers more in depthly. But I'll be back tomorrow if that's any consolation. Doffy. And like, yeah, so, and I had a bunch of content, you know, ready to go over. I still want to go over this of, you know, scientific fraud, some more LK 99 stuff. I'm probably, so tomorrow I'm probably just gonna devote most of or a portion of the stream to like smaller articles like this, just kind of like science news updates. I also have some videos that I wanted to, like, you know, watch. There's a video about IQ, a whole bunch of other things, and I still need to get to like the science memes in the Discord. So I might just like start off tomorrow, or maybe I should save that for Friday, kind of like an end of the week type of fun thing. I'm also contemplating doing some very casual gaming streams. Probably not any AAA gaming stream. Probably like really old school, like retro gaming, because that's mostly what I'm into, or what I mostly have like time for. Of like, you know, a game that's minimal investment. It's nothing fancy. Like I'm super old school. I'm like Tetris, Dr. Mario type of gamer, where, you know, I just downloaded a Nintendo emulator. I'm playing like literally old school Tetris from like the 80s or like early 90s. Yeah, I think 80s. This is not to say that like I do play the occasional like whatever recent AAA game. But yeah, the ones that I kind of like enjoy the most are like games that are sort of like puzzle solving, although I don't think Tetris is really puzzle solving, but you know, sort of in that category or adjacent to that. Yeah, maybe watch party tomorrow, maybe just like science videos tomorrow, or like, you know, a mixture of like some of the shorter news articles, like not this one, but like this one, and like this one about scientists are abandoning Twitter, or X, and then maybe just some science videos, because there are totally some cool science videos out there that are sort of on my watch list. But there's also still a bunch of research that, yeah, I do want to cover, or that I'm going to cover in future. I'm always collecting just more and more research that I want to cover, and I can never cover it all. But let's see if I can find someone to raid. It looks like, I don't think I've raided them before, but it looks like Moohoodles is streaming. They are essentially an astrobiology, science, and tech streamer. I think I'm gonna raid into them. Yeah, they're covering space and astrobiology. I'm gonna set up the raid to Moohoodles. I want to thank everyone that passed by. Doffy, always a pleasure. Super grateful to have you pass by. Thank you, Oily Olive, for passing by, and thank you for the update. I hope you're keeping well. Thank you, Bob Marley, and anybody else that I forgot. I apologize. Zeron, thank you. Always grateful. I do intend to be back tomorrow. Should be a little bit earlier of a start time. Should be. Can't guarantee it. Might be the exact same. But I'm going to aim to start maybe a little bit earlier. Maybe like half an hour or an hour earlier. But I will keep the Discord updated. I usually sort of like give some notice of when I'm about to go live. Or like I say, going live in about an hour. Yeah. If you're not following Mahoodles, you should be, because they cover awesome astrobiology news. And yeah, we're gonna raid into them. And yeah, good see me again tomorrow, and probably also Friday as well. And until next time, take care, be well, be kind, and if you're not following Mahoodles, you should be, for sure.
Definitive conclusion that nearby stars aren't sending cosmic hello greetings in our direction. Yeah, but like, you know, how much is it, right?